Hi everyone, welcome to Vedantu J English. I'm Diksha Kaushal, your chemistry master teacher. So everybody do let me know in the chat box if I am clearly visible and audible to all of you or not. Yes, very good afternoon, very good afternoon. And yesterday I was not at all well. I was so unwell. I'll tell you that what I did. Right, I was so unwell that I was supposed to send you this video, right, regarding that I am not well. So according to me, I have sent you this. My head was so paining, I had fever, I was like in some another zone only, that I have accidentally sent this video to Vedantu NEET English. And till now I was thinking that I have sent you this video. Then I saw that why students are saying that ma'am class will again, timing will change. Okay, I have told them then what was the reason. Then I saw that I have not sent you that video. I have not informed you on Telegram channel that why the class got cancelled yesterday or postponed yesterday. So reason was that only I was not at all well and in that state of speaking or standing, right? Even now I am like okayish, but still I'll manage to take the class, right? Okay, yes everybody. Read it a little in Hindi also. Ma'am, please read it a little. Hassan, I can very well understand and speak Hindi, right? Don't worry about that. But the problem is that this channel is JEE English, right? So English means I'll have to talk in English, right? This is actually for all those students, right, who know their regional language and English, right? They don't know Hindi, right? And this is also Hindi students can also watch this video, because I think right now in every school we have English, right? So it's a good medium to teach you, because your exam is eventually going to be in English, right? Okay, yes everybody, shall we start with the class? Tell me. So today we are going to do how many chapters? Tell me. We are going to do GOC. In GOC, we will do firstly IUPAC naming, then we will do electron displacement effects, like all the effects like inductive, resonance, hyperconjugation, aromaticity. Then we will do isomerism, right? In that also we'll do all the isomerism. That will be a big chunk. And after doing all of that, we'll start with hydrocarbons and purification qualitative quantitative analysis. Tell me, are you all ready for that? Yes everybody, tell me, are you all ready for that? Okay, I'll ask, okay, I'll ask. Please now focus here. Understand that these things are not in my hands. I am not someone's boss, right? Okay, I'm just a teacher. All I can do is I can teach you, right? Chemistry, that's all is in my hands, right? So understand that, right? Okay, tell me, shall we start with the class everybody? Shall we start? Yes everybody. Spam the chat box with red hearts, green hearts, so that I can see your energies also in the chat box. I want to see your energies in the chat box. Yes everybody. Yes. Say I was not well, still I am here. You know that what conditions I am going through right now, right? It's like my full body is in pain right now, but still I am standing only because of you. Because I know that you have your exam. Otherwise I would have taken complete 1 week of rest here, right? Sure. Yes, NEET aspirants can definitely watch this. This is equally helpful. Plus, I am not taking any kind of PYQs here. So, it's the same for NEET and JEE. So, I'll just send it on NEET as well, that I am taking the class. Wait a minute. So that NEET aspirants can also join in, right? Let's start. So guys, first thing is, let's talk about IUPAC naming. The first topic is IUPAC naming. Now why it is so important? Because in the questions, sometimes in the question itself they ask you like what is the name of this compound, this and that. Sometimes direct question is asked on polyfunctional groups, or they can ask you N, iso, neo, these kind of things they can easily ask from IUPAC naming. So let's focus on that. This will be a rapid recap, so let's do that. First thing is, according to the number of carbon of parent chain, how you will write it, right? In case of 1 carbon, you will write it as meth, 2 carbon is eth, 3 carbon is prop, 4 carbon is but, 5 carbon is pent, 6 carbon is hex, 7 carbon is hept, 8 carbon is oct, 9 carbon is non, 10 carbon is dec, and 11 carbon is do dec. Okay, so till 11 it is more than sufficient for use, right? So I'll just write for 9 and 10 as well. For 9 it's non, and for 10 it's dec, and for 11 it's do dec. Okay, that's it. You know this one, that's absolutely fine, right? Now let's talk about, wait a minute, now let's talk about one by one the rules of the IUPAC naming, right? So if I talk about this particular compound here, any simple compound you have, firstly you will calculate what is the longest parent chain here, right? So if I talk about longest parent chain, 1, 2, 3, 4, 5, 6, 7, 8, 9, this becomes the longest parent chain. If I start from here, I will give numbering 1, 2, 3, 4, 5 here and 7 here. Now second rule is lowest locant rule. That means the substituent should have the lowest value here, right? So for the substituent to have the lowest value, I will start it from here 1, 2, 3, 4, 5, 6, 7, 8, 9, and here on 5th position and 3rd position you will have the substituent. So that is why 3-methyl, this one particular position here, if you talk about this is CH3, this is CH2, CH2, CH3, that means this is total propyl, right? So 3-methyl 5-propyl nonane is the answer here. Let's talk about next compound here, where we have, I'll just write the naming also, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Now let's talk about this one. Next is when you have alkene, right? Then alkene, you will just replace like this is alkane, okay? This is alkane. For example, methane. If you have methane double bond, you will just replace ane with ene. That will be the thing. Ane is replaced with ene here, right? So now what we are going to do, again we will select the longest carbon chain here, that is 1, 2, 3, 4, 5, 6. Why not 1, 2, 3, 4, 5, 6 same is? It is equivalent, so you can start from here or here, both of the sides. I'll start from here 1, 2, 3, 4, 5 and 6. That is going to be hex, then 3 and ene, right? So it is hex 3, ene is the correct answer here. Now let's talk about the next one, where we are going to start, because we want to give. Now if I talk about the priority, right? When you select the longest chain, you also want to see the numbering here. Numbering you will see from the substituent and from the multiple groups as well. So substituent should have lowest number, and also multiple bonds also should have the lowest number here. That is why I'll start from here 1, 2, 3, 4 and 5. That is going to be pent 1 ene. Pent 1, because on 1 position you have ene. Pent 1 ene is the correct answer here. Now let's see other things here. Compounds containing cyclic and chain parts. So when there is cyclic and chain parts here, cyclo and state chain having more number of carbon is the parent chain is selected. That means if I talk about this thing here, this is how many carbons? 2 carbon. This is 1, 2, 3, 4 carbon. Now which will be selected as the parent chain? Which one will be selected as the parent chain? This one will be selected as the parent chain. That is, we'll start from here 1, 2, 3, 4. And on first position, what is the substituent? This substituent is called as ethyl. Why? Because 2 carbons are there, so it is ethyl, right? So we will say 1-ethyl cyclobutane, okay? Now, if I talk about this part here 1, 2, 3, 4, 4 carbons. Here you have 1, 2, 3, 4, 4 carbons. And okay, let's talk about this later on. This we'll talk about later on. Firstly, let's talk about this thing here, right? That is, in this case, you have 1, 2, 3 and here 1, 2, 3, 4. So if one is cyclic, other is open, which one will be selected? With more carbons will be selected as parent, right? So here this is selected as parent because this has more carbons. Here this will be selected as parent because this has more carbon. 1, 2, 3, 4. So answer is going to be 1 cyclopropyl. Whenever anything is acting as a substituent, instead of cyclopropene, we say propyl. What is yl, right? This is alkane. If you take out one hydrogen from alkane, make it a substituent, that becomes alkyl. That's why cyclopropane is called as cyclopropyl. Okay. So here I'll write 1 cyclo, wait a minute, 1 cyclopropyl, and this is butane, that is the parent chain here. Now in this case you have 1, 2, 3, 4 carbons here, right? And here also 1, 2, 3, 4. When number of carbons are same, then what is chosen? Tell me guys, when number of carbons are same, then what we choose? Tell me everyone, everybody. If number of carbons are same, then what is selected? See, if same number of carbon is open and closed chain, then cyclic chain is selected as the parent chain here, okay? Then cyclic chain is selected as the parent chain here, right? So if I say the number of carbons are 4 here and 4 here, then this will be selected as a parent chain 1, 2, 3, 4. So it is going to be on first position. What you have, this is nothing but this is 4 carbons, so this is butyl. So we'll say 1 butyl, butyl, then this is cyclobutane. Okay, 1 butyl cyclobutane will be the correct answer here. Got it? If there are different numbers in cyclic and open, then the one which has more number of carbon will be selected. If same, then cyclic will be selected. These are the 2 rules that we have applied here, right? Next is multiple bonds have same priority, have more priority than substituent. Now next is multiple bonds have more priority than substituent. Let's talk about this with the help of an example. So you have this thing here, right? Now here I firstly want to select the longest chain. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, that is the longest chain, that is for sure. Now if I see multiple bonds have, that means I want to give less number to multiple bonds. Everybody tell me, I want to give less number to which thing? To multiple bonds, right? So multiple bonds have more priority, they want to get less number, right? So I'll start it. If I start 1, 2, 3, 4, this will get 4th position. If I start 1, 2, 3, this will get 3rd position. So definitely I'll start from here. 1, 2, 3, 4, 5, 6, 7. If there is no multiple bond here, let's say this thing is not here only. Let's say this multiple bond is not here. Then what you will do? Then you will say, ma'am, now substituent is the priority for us. Ma'am, now I will see alphabetically. I will give less number to alphabet which is having like A, B, C, D order. So this has less number. This is B and C is after B, right? So I will do 1, 2, 3 here. Got it? Right? Okay. But now here we have double bond. So I will give the opposite order here because multiple bond we will get respect to. Then substituent we are like, okay, whatever substituent, right? So here you have 5 fifth position. Now when you are writing the IUPAC naming, you see, we know that on 3rd position you have chloro and on 5th position you have bromo. But while writing, you will write it in alphabetical order only, right? So it will be 5 bromo, 3 chloro, hept 3 ene. 5 bromo, 3 chloro, hept 3 ene. Okay? Now let's say we have, next is, if more than one double bond present, then suffix is A, right? What do you mean by that? 2 double bonds or multiple bonds are present here, then what we will do? We will start from here, 1, 2, 3, 4, 5, 6. This is going to be hex 1 and 3 diene, right? So you are supposed to write it hex. Those who don't know this rule, they will write hex 1, 3 diene, 2 enes are there. But what is the rule? The rule says that if more than one double bond is present, then you will apply hex A here. That means you will add A here. That's why it is written as hexa, not hex. Okay. Next rule is multiple bonds have more priority than number of carbon in parent chain. Multiple bonds have more priority, we are saying. Multiple bonds have more priority than number of carbon in the parent chain. So here I have 2 options. Okay. Here I have 2 options. What are these 2 options? Tell me what are these 2 options. The option is that I'll see 1, 2. If I want to select the longest chain, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 carbon, ma'am, select this. But if I select this, multiple bonds will be out of my parent chain. But multiple bonds have more priority. So they should be inside the parent chain. If I am saying they should be inside the parent chain, in that case, what I will write here? I'll definitely write here like this: 1, 2, 3, 4, 5, 6. So here it will be, here it is propyl, this is propyl and this is butyl. So you can write it as, because B is before P, so you will write 4 butyl, sorry, wait a minute. This is B now, this is P. So you have to write the numbering oppositely. So you have to write it 1, 2, 3, 4, 5, 6. So you will write it 3 butyl, 4 propyl and then hexa, because 2 multiple bonds are there. Hexa 1, 5 diene, because it is triple bond. So it will be ine, diene. Right everyone? Okay, done. Let's see. Next is, I think all the 3 rules we have done here. All the 3 rules we have done. Now next is when substituent is complex. If I say the substituent is quite complex here, then what we will do? Right? If the substituent is complex, then what you will do? Tell me everyone, if the substituent is complex. See. In this case, if I am saying the substituent is complex, in that case, what I will do? 5,1,1 dimethyl propane. Acha, wait a minute. I'll do one thing for you. There is one more thing. So I'll tell you this after like 5-10 minutes. Right? Firstly, let's see this. Right? In this case, you have 1, 2, 3, 4, 5, 6, 7, 8, 9. That means if I want to have the longest chain, this substituent will become complex. So how do you name the complex substituent? We will firstly make it in a box. Right? How do I name this? I'll number this 1, 1 dash, 2 dash, 3 dash. So this is going to be 1 dash, 1 dash, dimethyl, 2 methyls are there, and this is propyl. Overall this is propyl because 1, 2, 3 carbons are there. So I'll name it 1 dash dimethyl propyl. This is the substituent. I'll put the substituent in the bracket. Then I'll say this is 1. The numbering of this overall chain is 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'll number it 5. This is 1, 2, 3, 4, 5. Here also it is 5. So I'll number it as 5 1 dash 1 dash 1 dash dimethyl propyl nonane. Okay, 5 1 dash 1 dash, or you can just simply write it as 1 1 dimethyl propyl nonane is the correct answer here. Now what about this one? If I number this 1 2 3 4 5 6, this is going to be the complex substituent, isn't it? Now to write the complex substituent, how I'm gonna write it here? 1 2 3. So this is going to be 1, again same, 1 1 dimethyl, on 1 1 you have dimethyl, and this is dimethyl propyl. Why? Because overall 3 carbons are there, on first position 2 methyls are there. This is a complex substituent, right? So you will write it as 3 propyl. Wait a minute. I think, okay. Wait a minute. Let's see if the longest chain can be anything else also. I think the longest chain here was what? 1, 2, 3, 4, 5, 6. 6 carbon. 1, 2, 3, 4, 5, 6. Okay. In fact, this also cannot be the answer. Wait a minute. Let me see longest chain here. If I see the longest chain here, the answer will definitely vary. 1, 2, 3, 4, 5, 6, 7. This also can be the answer. So you can also write it as 1, 2, 3, 4, 5, 6, 7. That means now you can write it as 3, 3 dimethyl, or 4 pe you have ethyl. So you can write it as 4 ethyl. This is ethyl. On third position you have dimethyl, 3, 3 dimethyl. It's not like you have to forcefully make it complex substituent. If it is, there is no other possibility, then make it complex substituent. Okay, 4 ethyl, 3, 3 dimethyl, and this is heptane. So here answer is going to be this. Okay, now let's talk about the functional groups here. Yes everybody, now let's talk about the functional groups here. So see, in the function group alcohol, that is OH has ol, ether has ROR, right? So that I'll tell you how to write ether here. Aldehyde has suffix al, ketone has suffix on, like ketone, right? Carboxylic acid has oic acid here, ester has O8, right? Then amide has amide, and acyl halide has oil halide. So one by one we'll see that. Achha, let's see the other also. Alkyl halide also I'll tell you. Anhydride is like oic acid. Similarly here will be oic anhydride. Alkenes will be ene, alkynes will be ine. Now you will better understand with the help of examples, right? So one by one I'll give you the examples here. Firstly, if I talk about alcohol, right? In the functional group has even more priority than the multiple bonds, okay? So here what you will do, you will start it from giving the functional group the lowest number here. So it will be 1, 2, 3. On third position you have OH, that is alcohol. So you will write 1, 2, 3, 4, 5, 6. So this is going to be the longest chain. Answer will be on fifth position you have 2 methyl. So 5, 5 dimethyl. This total is hexane. So how do you write it? You write it as hexane, right? Whenever substituent is attached, so you replace this E with ol, right? So on third position it is, so you will write hexane 3 ol, right? Now if I talk about this one here, here you have double bond as well, here you have OH also. Now which one has more priority? So the priority order is always maximum priority is of functional group, then you look for multiple bond, then least priority is of substituents, right? So here when we write it, we'll write it like this: 1, this is 1, 2, 3, 4 and 5. Now in this case, this is going to be the priority, so second ol it will be there, and here 3 is your E. So how I will write it? Firstly, I'll just write it for you here. See how I will write it. You have pent on pentane, right? Pentane will be the normal thing. Now when I talk about there is ene, so what I have to do here, I'll replace an with ene. And where is ene? Ene is here. on third position. So you write 3ene. And on the second position you have ol. So on the second position you have ol. Now see this thing very, very carefully. When the rule is cut E in the suffix of parent chain, this. When E is followed by A, I, O, U or Y. If after E, anywhere in the suffix you have A, E, I, O, U, Y, you will cut it, right? Similarly, here it was supposed to be hexane 3-ol. We cut E because after E you have O. Understood? So that is the reason here answer will be pentane 3-ene 2-ol. This E we will cut from here as well. Okay, that is the rule. Now let's talk about ether. Ether is when you have CH3O, CH, I told you I will tell you this with the help of example. Now here it is written as alkoxy-alkane. Now what is alkoxy part? What is the alkane part? Right? Alkoxy part is chain with less number of carbon. Right? So here it is symmetrical only. I will make one unsymmetrical here. Okay, I will make one unsymmetrical here so that you know what is going to be the answer here. See, so if I make here OC2H5, this is CH3. Then what will be the answer? If I make here O, this is CH, CH3, CH3. Okay. This is CH2, CH3. What is going to be the answer in these two cases? Let's understand that. So alkoxy part is with less number of carbon. So that means this will be methoxy, right? So you will write it as methoxy, methoxy, right? So here carbon is methoxy. Here it is more number of carbon is the alkane part. So it will be ethane, methoxyethane. Okay. What about this one? This is less number of carbon. So this is the alkoxy part. This is the alkane part. So how do you write it? Everybody tell me in the chat box. This is going to be ethoxy. Ethoxy. And what about this one? This is alkene. So this is, I'll tell you what this group is called. This is called as iso group. Okay. This is called as iso group. So I'll tell you right now, just remember that this group where carbon is attached with two methyl groups, that is called as iso group. Okay. So this is isopropane. Okay. Tell me. Is that clear? Understood? Right? Is that clear, everybody? Done? Now let's see about ketone. Right? Now let's talk about ketone here. Now I'll talk about 2-3 ketones here, not one. And I'll talk about 2-3 aldehydes here. Okay? Let's talk about aldehydes and ketones. Let's see. So if I see ketone here, let's see what is the answer for CH3 C double bond O CH3. What is the answer for C2H5 C double bond O CH3? Right? Okay. Then what is the answer for C3H5 C double bond O C2H5? Okay. Or you can also write it like this. CH3, CH2, CH2, C double bond O, CH2, CH3. See, let's talk about the first one here. Let's talk about this one here. In this case, this is prop, and here you have on second position you have on. This is 1, 2, 3. So you can write prop to on. But if you write prop to on, I have written propane to on. Wait a minute. This should be propane to on. Or you can also write it as propanone. Both are right. That means you don't have to mention here 2. Reason? Because even if you don't mention, there is only this possibility where double bond O can be there in 3 carbons. If you have double bond here, this is CH3, this is CH2. Let's see, you have double bond here. This is C, this is the double bond. Then this will become aldehyde. So that is why only possibility in 3 carbon is propanone can be propane 2-on. There is no other possibility. So propanone or propane 2-on both are correct. But if I talk about this one here, in this case you have to mention. Why you have to mention here? Because if I write it fully here, right, this will be CH2 and this will be CH3. That becomes C2H5. Now if you don't mention here 2, it can be here, it can be here. If it is here, now here also you don't need to mention. Because it can be here, then also it is 2. It can be here, then also it is 2. If it is here and here, then it will become aldehyde, right? So that is why here also you can write butane 2-on, or you can also write it as butanone. That is the same thing, right? Now do I have to mention here? Here I have to mention, because if double bond is here, then it is different. If it is here, it is 2, it is 3. If it is here, it will be 4. So that is different. So that's why I have to mention 1, 2, 3, 4, 5, 6. So here you can only write it as hexane 3-on. If I write here hexanone, that is not correct. That is not correct. So I'll mark wrong here. That will be wrong. Okay? Right? Understood? Now let's talk about aldehyde here. Aldehyde again, quite simple. Right? So if I talk about aldehyde here, very simply what you will say, aldehyde is on the terminal position. There is no talk about it only. Let's say CH3CHO. You have C2H5CHO. Right? Let's say you have CH3CH2CH2CHO. So anything you can write here, that is the same thing. So here 2 carbons are there, that is why it is called as ethanol. Right? You don't have to mention, because always it is on the terminal position. This is 1, 2, 3, 4 carbons, so this is butanol. Okay? This is 3 carbons, so it is propanol. Right? So always this is going to be in the terminal position, always and always, right? Now let's see your acid. Acid always it is going to be, if you talk about acids here, right? In the case of acids, always remember, if I talk about this one or this one, acids also is quite simple only, right? Acids also just always they are terminal groups, okay? So you have CH3, COH. Or you have CH3, CH2, CH2. Always it is on the terminal position, so you don't have to mention anything here. This is total 2 carbons, so it is ethanoic acid. Ethanoic acid. 4 carbons, so this is butanoic acid. Butanoic acid here. Okay. Now what about this one? This is also the terminal, and here always, like in the acid you have oic acid, in the acid halide you have oil halide, right? Oil, you do your massage with oil, so oil halide, okay? So here 1, 2, 3 carbons, so it is propanoyl chloride. So here also I will mention some 3, 4 things here. Very simple it is, okay? The terminals, so you don't even have to think about anything. Let's say you have CH3, CH2, COCl, right? Let's say you have 1, 2, 3, this is COBr. What you will answer here according to this? So here it is going to be 3 carbons, so this you will write it as propanoyl chloride. Okay, oil halide now. So here it is 1, 2, 3 and 4. This is the substituent. So you will write 3 methyl. On third position you have methyl. and this will be butane oil bromide. Okay, this will be bromide, right? Okay. Acha, tell me one thing. If here I have, let's say here I have, let's variate something here, right? Let's say here I have Br. So what you will write here? You will write it as 1, 2, 3, 4. You will write 3 bromo, that is the substituent. But it will start from here only. Function group has the highest priority. 3 bromo, then this is butane, then 1 oic acid, always butanoic acid. Okay, that's how you write with the substituents here, right? Okay, now we are going to level up a little bit because this is just for your knowledge. I am telling you all of this. If you have forgotten about this, right? This also I'll write different names here, right? Acha, see. Now this is called as amide. So let's say you have simple CONH2, right? Then let's say you have 1, 2, 3. NO2. NO2 is also substituent. Now what you will do? Now I have added substituent in the function groups. Okay. Now think accordingly. Now if I see, this always starts from terminal, so it is 1, 2, 3, 4. So it is going to be butane amide. So it is butanamide. You don't have to write 1 or 2 here because it is a terminal position. Okay, terminal function group. So here it is 1, 2, 3, 4, 5, 6. So on 5th position you have 2 methyl groups, that is M. Mn. N is before M. So this is methyl. See, these are methyl. This is also methyl. This is nitro. So what I will write? I will write nitro first here. So I will write 3 nitro. Then you have 5, 5 dimethyl, 3 nitro, 5, 5 dimethyl. Then you have hexanamide, hexanamide. Okay, understood? That's how you're going to write it. Tell me. Okay, acha. Let's talk about anhydride here. Let's talk about anhydride here. Let's talk about anhydride. How anhydride is formed? Anhydride is formed from the these acids, right? So that's why how you are going to write anhydride. Let's say CH3, CH2, C double bond O, C double bond O, CH3. Okay. Let's say there is something else also, that is CH3, C double bond O, CH3, CH2, C double bond O, C double bond O, CH2, CH2, CH3. Okay, by this only you will be able to understand what I am telling. So firstly you will have this, how many carbons here? You will write it, right? So you will write it, this is 3 carbon, here you have 2 carbon. So alphabetically you will write it firstly E, then P. So you will write ethanoic, because they are formed from acids. So this is ethanoic, this is propanoic. Instead of writing acid, you will write anhydride. Okay. What about this one? Here you have which thing? You have 3 carbons here. Here 1, 2, 3, 1, 2, 3, 4 carbons here. So that is going to be P, prop. This is going to be B. So you will write firstly B here. Butanoic. Then you will write propanoic. Then you will write anhydride. Okay? Butanoic, propanoic, anhydride. Very good, Yashwant. Very good, very good, very good afternoon, beta. Not good evening. Yes. Right, I'm going out of the class. Okay, Hari. Chalo. Now let's see. Next is ester. What about ester? How do you write ester? Let's talk about that. Okay, 3-4 compounds I'll write for ester as well here. For ester, let's say you have this C double bond O, this thing. Okay, chalo, I'll just write this much. So how do you write it? In this case, the name is alkyl alkanoate. Alkyl is with oxygen. I have written ketone only here, right? So this is with oxygen like this. So this is with oxygen is the alkyl part. So this is the alkyl part. This is the alkanoate part. Okay, so you will directly write it as alkyl alkanoate. So this is ethyl. So you will write ethyl. This is not ethyl. This is methyl. There is one carbon here, no? So this is methyl, and this is 2 carbons. So this is ethanoate. Okay, understood? That's how you are going to write it. Yes, everybody, tell me. And if you see, ma'am, there is any substituent in this case, then what we will do, let's see, you have something like this. Okay, let's see, you have a substituent here. Then how you will write it? Right, let's see, you have a substituent here, then how you will write it. See, actually, alkyl part is the substituent here itself, and alkanoate part is the main chain. So main chain actually looks like this: 1, 2. Acha, one more thing, yaar. One more thing. This carbon should be included in the alkanoate part. So alkanoate part is actually not this thing. Alkanoate part is actually this thing. Wait a minute. Let me just correct it. This is the alkanoate part with the carbon. Okay, so alkanoate part is with C double bond O. So it will be methyl and this will be propanoate. Okay, because C double bond is included in the parent chain. So here the numbering is going to be, this is 1, 2, 3, 4, 5. So what you will say here? You will write 3 bromo, right? And other part, on the first carbon only, this is the alkyl part that you have, right? Okay, so this alkyl part is 3 carbon, 3 bromo propyl, and this is 5 carbon. So it is 5 carbon propanoate. Okay, yes, everybody, tell me, is that clear? Now is the main game that has started. This is the main game that has started, from where they ask you the questions. The order of polyfunctional group. This is the most important part of IUPAC, from where it is like, if you do this, if you're like, ma'am, I am weak in IUPAC naming, do this much, okay? Chances are, like, because if they ask you IUPAC naming, in JEE they ask you from polyfunctional groups only, right? Okay, because that is also like not very simple, not very complex, right? Okay, tell me, if they ask you directly the IUPAC naming, they ask you from polyfunctional groups only. So polyfunctional groups, how do we write it? We write it as, the order of decreasing priority is, firstly you have acid, then you have SO3H, then all the acid derivatives, firstly ester, then alkyl halide, then amide you have. After acid and its derivatives, you have triple bond, that is CN. There is also NC, This is CN, after this it will be NC, right? Then there is aldehyde. Then you have ketone. You have OH, amide, double bond and then triple bond. Okay, so this is like full. Instead of doing this now, instead of remembering this, remember this thing. Okay, this will be more useful for you. I'm just writing here polyfunctional group. Polyfunctional group list or order. Okay, so that's how you're going to remember all of this. This is very, very important. This is like with proper mnemonic. Cute Santa and Esther, Hallie ate chocolate ice cream, Edward King arranged the amazing event. So carboxylic acid, sulfonic acid, then acid derivatives like anhydride, then esters, then alkyl halide, then amide, right? Then cyanide, isocyanide, then aldehyde, ketone, alcohol, thiol, amines, then ethers, right? That is the full game that you should remember. If you want to actually, if you know this much, you're good enough for polyfunctional groups, okay? Right? Now see this, you can also remember it like this: acid, acid derivatives. After that you have triple bond, right? Then you have double bond, like you have ketone and all these ketone and this aldehyde, that is a double bond. Like first you have triple bond, then you have double bond, then you have single bonds, right? Okay, now when the functional groups are acting as main group, they have a different name. But when they are acting as a substituent, they have a different name. So when they are acting as a main group, alcohol has ol, amines has amines, ketone has on, aldehyde has al. But as substituent, they have different name. That is, alcohol is hydroxy, amine is amino, ketone is oxo, aldehyde is oxo and formyl. Okay, aldehyde is oxo and formyl, right? Acha. After this, what else you have here? What else you have here? Then ester is alkoxycarbonyl, acyl halide is halocarbonyl, right? Amide is carbomoyl, right? Then cyanide is cyano. This PDF will be provided to you as it is. You should remember this. Sulfonic acid will be sulfo, ether will be alkoxy as a substituent, right? Then this carboxylic acid will be carboxy as the substituent, okay, right? Let's see one by one, understand this. Yes, everybody, let's one by one go through them. Tell me. Now let's talk about this, that is CHE, CH2, CH2, CHO, right? Yes. Tell me, tell me, tell me. PYQ session. Practical chemistry, that I don't know, bacha. Okay? Practical chemistry will do, but I have not done till now. So I think you are asking for notes of physical chemistry, is it? Beta, I have talked to the team. They are saying they will upload it on Monday. So you'll have to wait for that. So in this thing, you have aldehyde and you have amines, right? This is amine and this is aldehyde. Which one has more priority? Aldehydes has more priority. So this will act as a substituent. So this will be 1, 2, 3, 4. On 4, this is acting as a substituent. As substituent, its name is amino. So it will be 3 amino. This is butanol. Okay, 3 amino butanol. What about this one? Here you have OH and you have NH2. So if you see this here, in this case OH is substituent or NH2? NH2 is the substituent, right? If you see it from the group itself, the list itself, right here, right? This is amine and this is alcohol. So alcohol is the primary group as compared to amines, right? So amine will act as a substituent here with the name amino, right? And it will start from here 1, 2, 3. So it is 2 amino propane, propane 1 ol, right? Okay, next is this one where you have C double bond O, you have alcohol and you have amine. 3 functional groups you have here. Beta, how much free you are? Don't insult your teacher like that by putting their name on someone else's classes. Don't make them ashamed of you. I would have been very much ashamed if my student is going on someone else like live class and distracting the teacher and the students as well. I would be ashamed of my student, right? Because you are actually, all the students is 5 days before the exams, they are trying to study, right? The teacher out there is trying to teach them in less time and more knowledge they are trying to give, right? So you are not disrespecting me, you are disrespecting your teacher. Don't do that, okay? Don't do that, okay? No teacher wants their student do all this in someone else's class. No teacher. I would be ashamed of my student if he or she does that, right? So here, now if I see this here, this is ketone, this is amine, this is alcohol. Now in this case, highest priority is of ketone, right? So that means these two are acting as the substituent. So this as substituent is amino and this as substituent is hydroxy. Now numbering will be done from here or here. A has less alphabet, right? So that is why it will start from here. 1, 2, 3, 4 and 5. So answer will be here 2 amino, 4 hydroxy, pentane, 3 one, right? 2 amino, 4 hydroxy, pentane, E will be cancelled because after the E you have O, pentane, 3 one. What about this one? Here you have, this is acid and this is ketone. Acid will have more priority. That means now ketone will act as the substituent. This is the substituent. Whenever ketone is acting as a substituent, it has the name oxo or it has the name keto, right? Any name you can give it. Now that depends upon the options, what name is there, right? So it will be how you will start it from here or here. You will always start it from the or from the main group. Here main group was this. Why we have not started from here? Because ketone is not a terminal functional group. Okay. So this is a terminal. So we will start from terminal only. 1, 2, 3, 4, 5. 1, 2, 3, 4. 3 oxo or keto. This is butanoic acid. 3 oxo. This is not written 3 here. 3 oxo or 3 keto butanoic acid. Right. Acha. Now what about this one? What about this one here? Very, very important. Let's talk about this. First function group, second, third and fourth. Tell me which one is here the priority functional group. That is carboxylic acid here, isn't it? The priority functional group is carboxylic acid. So that means others are substituent. This as substituent has the name sulfo. This as substituent has the name amino. What about keto? Keto, you can write it as oxo or you can write it as keto, right? This thing we will not write it here. This thing we'll use later on, right? So this is amino, this is sulfo and this is oxo, or you can write it as keto. So answer will be, if I write it here alphabetically, so it will start from here 1, 2, 3, 4, 5, 6, right? That means it is going to be hexanoic acid and here E we will cut, okay? So E we will cut because after E you have oic acid, so I will write it as hexanoic acid. E will be, we will cut, hexanoic acid, okay? Fourth position you have amino, then after that there is O and there is S. If you write O for oxo here, then S will be in the end, right? Because this is A, B, C, D alphabetically we are writing. Then we will write 2 oxo and then there is 3 sulfohexanoic acid here, right? Okay. Now let's talk about these two things here. Let's talk about these two things. Now we are going to do Aldehyde, you must have heard about aldehyde has the name oxo as well. It has the name formyl as well. So we'll talk about this here. Right now here, how many groups you have? 1, 2, 3, 4. Right. So I will take this as substituent, this as substituent, and this as substituent. This has the name hydroxy. This has the name aldehyde. Now remember one thing. Whenever aldehyde, I am writing it here. Whenever aldehyde is included or excluded, it has different name. When it is included, it has the name oxo. When it is excluded, it has the name formyl. Okay? It has two different names. Included and excluded will have different names. Okay? So, when it is included, it has the name. Now, in the numbering, if you see, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Now, this CHO is excluded here. Excluded means this will have the name formyl. Okay, this always has the name amino. So, answer will be, this is A, this is F, this is H. A, B, C, D, E, F, G, H. So, first you write A, then F, then H. So, you will write 5 amino, 3 formyl, 4 hydroxy. 5 amino, 3 formyl, 4 hydroxy, and overall it is a hexanoic acid. Okay, right? Achha, what about this one? In this case, what is, this is the main group, this is substituent, 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 and substituent. This substituent is hydroxy. This substituent is bromo. This is chloro. This is fluoro. If I talk about the numbering, it will start 1, 2, 3, 4, 5, 6. So you will do it alphabetically. Alphabetically, firstly it will be 5 bromo, then 3 chloro, then 6 fluoro, then 4 hydroxy. Then it is going to be hexane 2-ene. Not hexane, it will be hex 2-ene 1-oic acid. Okay? Hex 2-ene, wait a minute, I'll just write it here because it is not written right here. So I'll just write it, wait a minute. So it will be hex, instead of ene, it will be hex, how much ene? 2-ene. 2-ene. E and E will be cancelled because after this you have oic acid. Right? So, hex 2-ene oic acid. Right? Tell me everybody, is that clear? Is that clear? Right? Acha. Now see, next part, usually they ask you most questions from most questions are asked from polyfunctional group that we have done now. Okay, so you should know what is how to do the numbering, the basic rules, and you will be able to answer it easily. Right? Now see, if I say when carbon is not in the parent chain, these are all the terminal. These are all the terminal. We are talking about terminal functional groups only. I am only talking about terminal function group. I am not talking about any other function group here. Only the terminal function group if I talk about, right? CHO, COH, CO, Cl, CONH2, COR and CNO are terminal. When they are not included, if there is any case, usually in most of the cases, terminal functional groups are included in the parent chain. For example, they are not included in the parent chain and they are symmetrical or they are connected to a ring, they will have a different name. Like CHO will have carbaldehyde, this will be carboxylic acid, carbonyl chloride, carboxamide, then ester will have carboxylate, CN will have carbonitride. Okay, just remember this name. I will tell you how to use these names. Okay, so firstly we talked about symmetry. Symmetrical position is these kind of situations where now all the CHO groups, if I want to check the longest chain here, I will check it as 1, 2, 3, 4, 5. Now this will be excluded and these two will be included. If there are 3 CHO groups, they are same. So you can't exclude one and include 2. You have to either include all of them or exclude all of them. So that's why for this kind of situation, this will be the parent chain and all of them are excluded functional groups. CHO, when it is excluded in case of polyfunctional group, that has a name of formyl. But when it is excluded in this kind of situation where it is forming a symmetrical kind of compound, right, then it is called as carbaldehyde. So it will be propane and the suffix will change, right? It will not, this is not acting as a substituent. Remember one thing, CHO, when it is included as a substituent, see, CHO has 4 things, okay? So CHO, when it is acting as a functional group, if it is included, it is called as ul. If it is included, it is called as carbaldehyde. But CHO, when it is acting as a substituent, when it is included, it is called as oxo. When it is excluded, it is called as formyl. These are the 4 names of CHO where students get confused. Tell me, is that clear to everybody or not? Right? Okay. Now see, when I have propane, this will be 1, 2, 3 tricarbaldehyde, because here answer will be carbaldehyde because it is functional group but it is excluded, right? Acha. Now what about this one? Here all of them are functional group. This is CHO, this is CHO, but here it will be CH2CHO. Now see what is going to happen here, right? Now we will write on the second position, this is not carbaldehyde, so it will be written as methyl. This is acting as a substituent now, because to this parent chain directly CHO is not attached, it is CH2CHO, so that is called as methyl formyl. Why formyl? Because CHO as a substituent is excluded from the parent chain. Because if CHO is directly connected to the symmetrical chain, that is called as carbaldehyde. If it is not directly connected, it is acting as a substituent now. That is why it is called as formyl. So it is methyl formyl. But these two are carbaldehyde. So answer will be 2-methyl formyl propane 1,3-dicarbaldehyde. Okay. Now same situation here we'll do here. Now if I talk about this one, in this case it is a cyclic ring. Whenever COH is attached to a ring, it is again carboxylic acid or carbaldehyde. If you have CHO, you will call it as carbaldehyde, right? So everyone, all the names, if they are connected to the ring, they will have these names, okay? Example is this. In this case, you have cyclopropane. Now E I will not cut because after E you have C. That's why I have not cut any E here. You will see here as well. This is propane. E is there. This is propane. Also here also it will be E. Okay, here also E will be there. Propane. Why E will only be cancelled if after that you have A, I, O, U or Y. Only then E will be cancelled here. So this will be cyclopropane 1. This will be one position. On first you have carboxylic acid, right? And what about this one? In this case I'll start from here. This will be 1, 2, 3, 4, 5, 6. So it will be on second position. You have methyl formyl because when CHO is directly connected to the ring, it is called as carbaldehyde. When it is not directly connected, it is called as methyl formyl. So it is methyl formyl. So 2-methyl formyl, this is cyclohexane 1,4-dicarbaldehyde, right? What about this one? This is called as, now see this. This is a ring, this is CH2COH, right? Whenever this kind of, don't be overexcited and write it methyl formic acid or like that. No, right? Why? Because there is no such name for carboxylic acid. right? That is why it is written as, this is 1 and this is 2. This is a substituent here. So this is 2-cyclopropyl ethanoic acid. Okay? Understood? Tell me everyone. Now most of them are, you know, names only. Let's talk about that. After that, most of it IUPAC naming and this we have done only. Now I'll give you something for your homework as well, because there are so many different names that you need to remember. Okay, just go through them. This is all your NCERT names, right? So benzonitrile, benzene and CN here. Phenol is when you have OH. Toluene is when you have CH3 here. Benzoic acid is when on benzene you have COH. Benzaldehyde is when on this you have CHO. Acetophenone is when you have COCH3 here. Then styrene is when you have CH double bond CH2. Anisole is when you have OCH3 here. Aniline is when you have NH2 here. Benzene sulfonic acid is when you have SO3H here. Orthoxylene is when 2 CH3 are present, right? Paraxylene and that will be same. Para means when CH3 is present on para position. Metaxylene is when they are present on meta position. Achha, mesitylene is when 3 CH3 are present on the symmetrical positions, like that. Okay. Now phenol, toluene, anisole, all of this we have done, right? Achha. Then you have this also we have done, right? Okay. Chalo. You can also go through this. These are all the common names that they have, right? Okay. Chalo. Now let's talk about this one here. Why benzene is main and methyl and ether are substituent. Now a very simple rule here. When benzene is main and methyl and ethyl are substituent, in that case, if methyl and ethyl, for example in this case, in this case you have 1, 2, 3. This as the see, because in this case methyl is the substituent, this phenyl will be the substituent. So you can say 1 methyl, 1 phenyl propane. Okay. So it is in this case when you have methyl or ethyl as a substituent, then you take these as substituent and phenyl also as the substituent. Now if functional group are present on the structure, the one having the functional group is the main. Now if in any case, now this is also the same case. On this carbon you have methyl also, ethyl also, right? And you have phenyl also, right? Now if there is no chlorine, I will take ethyl as the main chain, this as main, and this will be the substituent. But if I have on the benzene any substituent like chlorine, bromine, etc. is there, then benzene will be taken as main. Right. So now this will be taken as main and it will be called as 1, 2, 3 and 4. On 4th position you have this particular group. Right. This is 5 and this will be 6. Okay. Now in this case you will say 1 chloro and 4. What is this? This is 1, 2, 3. On 4th position you have 1 methyl propyl. 1 methyl propyl, that is a complex substituent, and benzene. Right. What about this one? In this case again on benzene they also ask you these things here. Here what you will do, NO2 you have, Br2 you have, this you have. So you can also write it in terms of toluene. If you write it in terms of toluene, then this will be 1, 2, 3, 4, 5, 6. Then in terms of toluene this will be written as 2 bromo 4 nitro, right? So you can write 2 bromo 4 nitro. If you write in terms of benzene here, then you will write 1, 2, 3, 4, 5, 6. You will write 1 methyl, 2 bromo, 1 methyl, 4 nitrobenzene. 2 bromo, 1 methyl, 4 nitrobenzene. Alphabetically you will write. Okay. Achha, when you have this kind of situation, what you will do? You can write phenol here. You can write phenol. And for phenol, what you can write it here, 1, 2, 3. But see one thing, if I talk about polyfunctional, this is actually higher priority. So I will write it in terms of benzonitrile. Okay, so I'll take this as 1, 2, 1, 2, 3. This will be more 1, 2, 3 because this is actually bromo and this is hydroxy. So 3, 4, 5, 6. So this will be 3 bromo, 5 hydroxy benzonitrile because this has the highest priority. So that is why I'll start the chain from CN, right? Okay. Why this is 3? Why not this is 3? Because of alphabetical order, right? So that way you are going to solve this, right? Okay. Now let's see priority order here. Priority order is functional group is greater than multiple bonds is greater than substituent. Always this is going to be the order, right? This is always going to be the priority order. Now let's talk about this thing here. In this case, this is the main, this will be acting as a substituent and this is a multiple bond. Tell me which one will have more priority? Multiple bond. So answer will be here 1, 2, 3, 4, 5. So you will write 5 because this is acting as a substituent and this is excluded. When it is acting as a, now sometimes students write it as carbaldehyde. No, it is acting as a substituent. So this will be written as formyl. Okay, this will be written as formyl. So here 5 formyl cyclopent 2-ene 1-oic acid, or you can say 2-ene carboxylic acid, because when COH, this is the functional group, and I told you when functional group is acting, when functional group is attached to the ring, that has a name of carboxylic acid. Got it now? Why this is not carbaldehyde? Because this is not a functional group, this is a substituent now. Why this is not carboxy? Because this is not a substituent, this is a functional group. Functional group attached to the ring is carboxylic acid. Why this is not oic acid? Because this is attached to the ring, that is why. Okay? Understood? Now some last things here, that is bicyclo compounds. See, bicyclo compounds na, very rare chances that they will ask you this. So just a recap of this, that how you mention the names. Let's do bicyclo compounds. Okay, bicyclo compounds means when two cycles are connected to each other, two rings are connected to each other. Fused means when they have only 2 carbons in common. Bridged means when they have more than 2 carbon in common, right? So rules are, we will firstly select the longest ring here and go from maximum to minimum. We will always go from maximum to minimum here, okay? We will always go from maximum to minimum here. Let's talk about this. So here what you have, So in this case, we'll go from maximum to minimum. Longest chain is this chain, okay? We'll go from maximum to minimum means here longest chain will be selected like what? This is the longest chain. I'll go from here 1, 2, 3, 4, 5, 6, 7 and 8. So I am going from maximum to minimum. Longest chain I will select here first. Longest chain is this one. So I will go from this to this. 1, 2, 3, 4, 5, 6, 7, 8. Now while writing, firstly you will write bicyclo. Bicyclo, bicyclo. Then you will write a bracket. Bracket you go from maximum to minimum. Here in this case you have 4 carbons. In this case how many carbons are there? Wait a minute, not this one, wait a minute. So exclude these 2 carbons here. Here you have 1, 2, 3, 4 carbons. Here you have 2 carbons and bridged carbons are also 2. So you will write 4, 2, 2. 4, 2, wait a minute. Bridged carbon, the common carbons will not take. Hai na? Right? Then there is no bridged carbon. If here there would have been 1 carbon, I would have taken it 1. Because there is no bridged carbon here, so I will not take any carbon, that will be 0. So it will be 4, 2, 0. Then last is on 7th position you have ene. So you will write oct means total number of carbon are 8. Oct 7 ene. Okay. So now what about this one? Here both are symmetrical only. Any longest you can select. So 1, 2, 3, 4, 5, 6, 7. Okay. then 8. 8 you will start from here because we want to give the substituent lowest number. So 8, 9, 10. Okay, ma'am, why I have not started from chlorine? That is not in the rule. You have to start from here, right? So now if you see, these 2 carbons will be cancelled here. So it will be 1, 2, 3, 3 carbons here, 1, 2 carbons here. And here you have 1, 2, 3, 3 carbons here. So it will be 3, 2, and then common carbons are 3. Okay, bridged carbons are 3. So it is 3, 2, 3. So here the substituent is 8 chloro. So first you will write 8 chloro, then bicyclo, then bracket 3, 2, 3, then decane, because total you have 10 carbons here, right? Then it will be decane. Okay. Acha, now Spiro compounds. In the Spiro compounds, it is exactly the opposite. Spiro compounds have only 1 carbon in the common, right? Only 1 carbon is connected here in common. So you start from shortest ring and you go from minimum to maximum, right? That means if I have these 2 rings here, this is the shortest, I will start from here. 1, 2, 3, 4, then 5, then you go from here. 6, 7, 8, 9, 10. If you have started, if you have ended here, 1, 2, 3, 4, this also you will start from here only. You can't say 5, 6, 7, 8. No, you go from here, right? 6, 7, 8, 9, 10, right? Now, instead of bicyclo, you will write Spiro, bracket. Here, how many carbons you have? 1, 2, 3, because this you will cancel. 1, 2, 3, 4, 5. Here it will be 4. So, it will be 4, 5, because minimum to maximum in the bracket. 4, 5, then it will be decane. And here you have, there is no double bond, so own will not be written here, okay? Decane. Okay, acha, what about this one? This one is, you will start any of this, I will start from here. Now, if I have both the same, now this and this will be chosen. Why? Because this is main and this will be acting as a substituent now, right? So, I will start from here. Not even, I will start from here only. So, it will be, if you see, but no, that we will not do, because we have to start from this point that is next to it. So, I will start from here 1, 2, 3, then 4, then I will do 5, then 6, then 7. Okay. So, it will be Spiro. Now, what is the substituent? Substituent is having the name formyl. Okay. So, you will say 5 formyl Spiro, bracket here. If you cancel this, 3 carbons are there. Cancel this 3 carbons. So, 3, 3 bracket close. Here it is decane. But in the decane, you have 7 carbon, that is heptane. So, it is heptane, and on second position you have carboxylic acid. This is a functional group that is connected to ring. That is why it has a name carboxylic acid, okay, instead of oic acid. Understood? Yes, everybody? Tell me. Acha. Isoneo, to I'll teach you, but not like this. Okay? Okay? I'll tell you how to remember isoneo everything. See. Bacha, tell me any problem? Now let's talk about isoneo everything. Right? That is a very, very important part that students get confused highly in, right? So, iso and neo, let's talk about that. Okay, everybody, tell me. Done? Firstly, let me complete the naming part, then I'll give you the break. Okay? Yes. Acha, now see, if I have to differentiate between isoneo, then what I will do? See, N means normal, right? Normal means what? If I have, let's say pentane, let's say propane, let's say butane, CH3, CH2, CH2, CH3, that is normal. If I have pentane, this will be CH3, CH2, 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 CH3, 5 carbon in a straight chain, right? N means normal, that means a straight chain. No branching is there, right? Now let's talk about iso. In case of iso, what you have? Iso means 2-methyl on 1 carbon. For example, you have something like this: CH3, CH3, and this is H. For example, you have CH3, CH3, and CH3. This is CH2, okay? This is CH. For example, you have CH3, CH3, CH, CH2, CH3, and so on. Now in all these cases, what you have here, you have this thing as common. What is that thing? On 1 carbon you have methyl. Actually, I can't mark it like this, so I'll mark it like this. On 1 carbon you have 2-methyl. On 1 carbon you have 2-methyl, right? So just calculate the total number of carbons here. Total number of carbons are 3. So it will be isopropane. This will, total number of carbon is 4. So it is isobutane. Total number of carbon is 5. 1, 2, 3, 4, 5. So it is isopentane. So how I am defining it is iso. I am just looking that this particular, all of them has 1 carbon which is connected to 2-methyl. Okay, I am just looking at that thing. Now if I talk about neo, 1 carbon connected to 3-methyl and 1 more carbon. That means if I say CCH3, CH3, CH3, H, carbon is connected. This is the same thing that I have written. C connected to 3 carbon. So those who have just learned, okay, carbon connected to 3-methyl, they will write, ma'am, this is neo. But this is not neo. This is not neo. Why? Because for neo it should be connected to 3-methyl and 1 more carbon. So here it should have 1 more carbon. Okay. So here you should have 1 more carbon. It can be simple carbon or whatsoever. This can be 3-methyl. 3-methyl definitely should be there, and then 1 carbon. Anything else can be there. CH2, CH3. So here answer is going to be, this is neopentyl, pentane. This is neo, how many carbons? 1, 2, 3, 4, 5. 1, 2, 3, 4. This is then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Neohexane. Okay, got it? What is N? What is iso? What is neo? Right? This is neo because of this particular group here. Because of this particular group here. 1 carbon connected to 3-methyl and 1 more carbon. That is the neo group here. Tell me. Tell me, is that clear? Is that clear, everybody? Tell me. Okay. So based on this, all these numbers, all these things I have written for you, all these are your from from NCERT, right? All these charts are from NCERT. Common names, what are important, everything is written here, so you can just go through them. I have made it in just one particular page. Reason being because you know you can't just go through NCERT right now, but you can definitely go through this particular PDF. Okay. At the middle of the second, let me just tell you secondary and tertiary also. Wait a minute. I'll just here only I'll tell you about secondary. See. Secondary is not related to N-isoneo. N-isoneo is a different definition. Secondary, tertiary is a different definition. So, if I say here, let's say, if I say this carbon is connected to 3 carbons. So, this is going to be tertiary here, right? I'll just write here. Here this carbon is connected to 3 carbon, that is tertiary. Here this carbon is connected to 3 carbon, it is tertiary. This carbon is connected to 1 carbon, that is primary. So, I'll just give you examples here only. Let's talk about this thing. This is secondary butyl chloride. That means it is what? It is 1, 2, 3, 4. Secondary means chloride will be there. Secondary butyl means 1 carbon is connected to 2 carbon. At that position chlorine is attached. That means chlorine is attached to that carbon which is further connected to 2 carbons. Right? Not 3 carbons. Right? So that is your secondary butyl chloride. Can it be written as iso? No. Right? If I talk about neopentyl, this will be neo position means 3-methyl. 3-methyl, 3-methyl, 3-methyl. Then 1 more carbon. Here you will have bromide. That means here, if in this case, if I talk about bromide, this bromine is connected to this carbon which is further connected to only 1 carbon. This is actually primary. But because of this thing here, it is called as neo. Okay. So this is what we had. Tertiary butyl. Tertiary means carbon is connected, bromine is connected to that carbon which is further connected to 3 carbons. So this will be the thing. That is bromine is connected to that carbon which is connected to 3 more carbons. That is tertiary. Okay, that is the difference in tertiary, primary and secondary. Tell me guys if there is any problem in that. So I can ask you like one thing here. One thing I can definitely ask you here, right? This will help you, okay, to understand this iso, secondary and all of that, right? See, and there is one more thing that I want to discuss before moving ahead. Okay, so 2 things I will discuss before moving to the GOC part, right? See, first thing here is that see one thing here, see one thing. So I am making these 4 structures here. You have to tell me which is what. So you have CH3, CH3, CH2, CH3. Okay. Then you have 1, 2, 3, 4, 5. Okay. Okay, you have this thing. Then you have okay, you have to tell me which is what in common names, okay, not in IUPAC name, in common name. N, iso, neo, primary, secondary, tertiary, you have to tell me, right? Okay. Okay. I think that is enough, right? So let's do one more. I think that is enough. Let's see. Okay, if you are able to answer this or not. Let's see. See, here, because this is a very important thing where students will definitely make mistakes, very silly mistakes. Here if you see in case of iso-neo, this group is iso group, carbon connected to 2-methyl. So I can say this, that this is isopropyl group is there. This is iso, not propyl. This is 1, 2, 3, 4, 5 carbon. So this will be iso 1, 2, 3, 4, 5. Pentane. So it will be isopentane. And if I write the number here, isopentane alcohol. Okay, so you can just write it like this now. So isopropyl alcohol, sorry. Okay, you can just write because this is wait a minute. Isopropentyl. Okay, you can just name it as isopentyl because this is the iso group. Total carbon is 5, so isopentyl alcohol. That means this thing, right? If I have to write it in terms of secondary, then OH is attached to that carbon which is further attached to 3 carbon. So this is tertiary group, tertiary alcohol, 3-degree alcohol, right? Should I write it in terms of tert? You don't need to because already iso is there, so iso is more preferred here, right? Now what about this one? This is carbon connected to 3 methyl groups with 1 more carbon. This is a neo group. So you can say neo, this is 1, 2, 3, 4, 5 pentyl alcohol. But this OH is connected to that carbon which is connected to only 1 carbon. So this is a primary alcohol. Okay. What about this one? That's why I am saying that there is no connection only. So you don't have to forcefully do it. Right. Now what about this one? In this case what you have? No iso, no neo. This OH is connected to a carbon which is connected to 3 carbon. Right. So this is not even directly tert here. Right. Okay. This is actually directly tert here. OH connected to carbon that is connected to 3 carbons. So you can just write it here, tert butyl alcohol. Okay. In this case you can't write anything. Okay. So this you can write tert butyl alcohol. This is not iso, not neo. Just write the every compound will not have a common name. Okay. So this will not have a common name. Not tert. This is not, you can write iso, this is not neo also, right? But OH is connected to that carbon which is further connected to 3 carbon, but so it is a tertiary alcohol. That we know. Okay, understood? Acha, then there is one more thing. See, there are 3 kind of things that we write. Okay, so one is we write about allyl, then we talk about vinylic, then we will talk about arylic, then we talk about benzylic. This is very important. Okay, for your common names only, this will help you. See, allylic means when 2 carbons which has double bond, it is connected to 1 carbon and to that carbon some group is attached. This carbon is the allylic carbon which is connected to a double bond, right? Itself it is not a double bond, it is connected to a double bond, that is allylic. When the group is attached to that compound, that particular carbon which is double bond, this carbon is a vinylic. When group is attached to that carbon which is a double bond, that is vinylic. If I talk about arylic, that means on the benzene only. On the benzene only you have the group. That is arylic. But benzylic is when on the benzene you have a carbon, this group is connected to that carbon, this thing is called as benzylic. Okay, these are the 4 simple like statements that you should remember. Then these are all the compounds, all the names that you should remember, right? I have given you direct of these are just the like important names from your NCERT. Okay, so before the exam, do have a look at all of these, right? Tell me, clear? Done everybody? Okay, chalo. Now definitely you should watch it. Achha, now I'll give you break, and after the break we'll start with the GOC. Okay, after the break we'll start with GOC. GOC means all the electron displacement effect, acidity, basicity. So it is going to cover like most of the thing. Then we are going to cover isomerism, right? So that is going to take a lot of time, right? Okay, understood? Chal. Now I'll give you break of like 15 minutes. Okay, I'll give you 15 minutes break now. It's 1:49 and I'll see you all at 2:05 p.m. and we'll start with GOC. Okay, the class will be resumed. GOC means we are going to start with electron displacement effect, acidity, basicity, all of these we are going to do. Right? Okay? Chalo. Yes. Chalo. Okay, then I'll see you all after the break. Hi guys, so my lunch was actually not ready. So just give me a second, I'll need more time here. Right? So it's 2 and I at least need 15. So I'll resume the class at 2:20, okay? So I need to have lunch because, that's the right time. After that, the break will be there at 4 p.m., which will be too much, right? So that is why I'll see you all at 2:20 p.m. and please have your lunch before the class, before resuming the class, right? Then don't ask me, ma'am, please give me another break. I'll give the another break at 4 or 4:30, right? Okay. Okay, so yes, everybody, tell me if I am clearly audible and visible to you. Tell me, everyone, if I am clearly visible and audible to you. Do let me know in the chat box. Okay, so shall we start with the class, everyone? Let's see, let's start with the class. So now we have GOC, right? In GOC, let's see what we are going to do here. Firstly, we are going to learn all the electron displacement effects here, then their applications in acidity and basicity. Right, so let's see. Now, guys, when we talk about organic chemistry, there is reactant. Reactant reacts with a reagent, right, in presence of some solvent. Then it goes through transition state or reaction intermediate and it forms the byproduct here, right? Now, these electron displacement are going to help you with understanding these reaction intermediates. That means from these electron displacement effects, we'll be able to understand the stability of carbocation, carbon ion and free radical here. Right. So let's discuss that one by one. First is electron displacement effects. First is there are like two kind of effects, that is permanent and temporary, right? Permanent effects are inductive effect, mesomeric effect and hyperconjugation effect. So one by one we'll talk about that. Then there is temporary effect, that is electromeric effect. So permanent effect, they do not depend upon the external reagent. Without the presence of external reagent, they are happening, right? And temporary effects are that needs the presence of external reagent to take place, right? Now, first is what is inductive effect. Inductive effect is due to the electronegativity of an element, right? So we say that, for example, carbon and hydrogen you have, and you have carbon and any electron donating group. So what will happen, electron donating group in the sigma bond itself, it will donate, it will give, for example, the electron were initially here. When you apply some, when you add some electron donating group, the electrons are shifted here, right? That is called as electron displacement. That means in terms of inductive effect, in terms of an element which shows inductive effect, the electrons are displaced within the sigma bonds here. So here they are displaced from this position. Initially they were here and now they have displaced here, because we are donating the electrons, so these electrons are displaced towards the carbon. When you have electron withdrawing effect, let's say initially you have electrons here, and when you withdraw the electrons, electrons will be displaced towards the element which is more electronegative. That means electrons are towards that side where more electronegative element is present. So we say it operates only on sigma bond. It is distance operated, right? As let's say you have carbon, 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 and this is halogen. Here effect will be larger, here it will be smaller, even smaller, even smaller. So effect will keep on decreasing with the distance. Then results in development of partial charges because of the difference in the electronegativity. Now these are the plus I effects here, right? This has CH2 has maximum, then NH negative, then O negative. This is the order here. In case of alkyl groups, 3-degree alkyl, then 2-degree alkyl, then primary alkyl, and after primary alkyl you will have methyl. And in case of tritium, deuterium and hydrogen, TDH is the order, right? Now what about minus I effect? This is the order of minus I effect. you have OR2 positive, OH2 positive, NR3 positive. This is going to be the whole order of minus I effect, right? Now, how it is operated, let's talk about that. So guys, when I talk about inductive effect, right? How it is operated, let's talk about that. So here you have distance, these are weak multiple groups here, right? Actually, my health is not fine. That's why I'm not able to put that much energy here. I'm not even able to manage this watch here. Wait a minute. So I'm just, trying to teach you right now. So my legs are, I don't know. So my health is like from past 1 week. The moment I teach, I only have the capacity of teaching you like 1 or 2 hours. After that, my energy drops like this. So if you feel that yeah, energy is low, yes, it is very, very low, right? I'm just trying not to faint here, right? So just see distance, then multiple weak multiple groups, then strong single group. So what we are saying here, if you talk about these two things, here distance is fluorine, here distance is same, and there are two groups. This is single group, but that is strong single group, and there are weak multiple groups. So in this case, multiple groups will have more priority. That means even if you have weak multiple group, that will have more priority as compared to single group. So that is why this will have more minus I. This will have less minus I. Now from the carbocation, how we understand the carbocation? From the carbocation, when you give the electrons, it becomes happy. When you take away the electrons, it becomes extremely sad, right? So when you give the electrons, you're taking away the electrons here. So when you take away the electrons, with more strength you take away. That means we can say for a carbocation, it is directly proportional to electron donating group and inversely proportional to electron withdrawing group. So that means more is the withdrawing power, less will be more is the withdrawing power. If the withdrawing power is very high, then the stability is going to be very low. If this is very high, this is going to be very low. Stability will be very low. So here it is more. That is why stability order will be this, right? What about these two things? Here distance. Here you have strong group, but that is like more distance. Here you have weak group, but with less distance. So you will prefer always distance. Even if it is a weak group, but with a less distance, it will have more minus I. Okay, so here you will have more minus I. Here you will have less minus I. So that is why more minus I means less stability. Answer is going to be A greater than B is the correct answer here. Now let's talk about next thing here, that is resonance. Now in case of resonance, what you have, the shifting of pi bonds, right? Delocalization of pi bonds. So in this delocalization, we have three categories here. One is double bond and p orbital, then alternate double bond, then you have back bonding. So in case of double bond and p orbital can be lone pair, p orbital can be negative charge, p orbital can be positive charge, and p orbital can be a free radical as well. Okay, so many things can be there, right? Okay, understood? Now, if you see this here, what will happen? Double bond, single bond and lone pair. Whenever you have double bond, single bond and lone pair, you will shift lone pair to bond pair, and bond pair is shifted always to the negative charge here, right? And from where you are taking away the lone pair, there you will put positive. So that means here, I'll just do, instead of that, I'll just write it myself only. See, so what we are doing, single bonds will remain same and nucleus will remain same. That means atom will remain same. Double bond is, lone pair is shifting to double bond, and here you put a positive, and double bond is shifted to the negative charge. Overall it is neutral only. When it is negative, then negative is shifted to bond pair, but when negative is shifted, there is no charge on E. Negative is shifted, there is no charge here, right? Then this is shifted to negative, right? Acha. After that, when you have double bond, single bond, positive, double bond is shifted here. That will be, double bond is shifted here, and this is going to be positive, right? Double bond will be shifted here, this will be neutral, this will become positive. When you have double bond, single bond, free radical, what will be there? There will be homolytic cleavage. So one electron will shift here and one electron will shift here. So you will have a free radical here, you will have a double bond here, and that will be your answer here. Tell me, is that clear? Right? So I don't know why I am even teaching you here. I sometimes feel like, why am I even here? If I am not well, why do I have to do it for you guys? Why do I have to? At least study when someone is not well and still they are here for you. At least respect them a little bit. This much you can do. Have I asked for a single penny from you? No? See, now you have alternate double bond, single bond. In alternate double bond, single bond, let's see what we are going to do. Okay. In alternate double bond, single bond, how it is going to remain? This will be CH2 as it is. This is CH, CH, CH2. Now, double bond is shifted here. Double bond is shifted here, and this bond will shift. When this double bond is shifted here, it will have negative. This double bond will be here. Because double bond is shifted here, so it will be positive here. So overall it is neutral only, right? But the sigma and nucleus, that means the atoms will not change their position. Now in case third, that is back bonding. In case of back bonding, let's discuss what we are going to do. In case of back bonding, what is the criteria and what we are going to do here? Let's discuss about that. So see, in case of back bonding, always there should be a pair of electron rich and electron deficient that is attached next to each other. Okay, electron rich and electron deficient pair that is attached with each other. Now if you see lone pair is shifted here, this will give rise to CH2 will be as it is, this is OH. Lone pair is shifted here, that will be a double bond, this will be positive here, and here that is the overall shifting. So this is electron rich, this is electron deficient. Now this is electron rich and this is electron deficient. Can you tell me how? Because boron does not have completion of its orbital, so electrons will be shifted here. This will be CH2 double bond BH2, right? And here, because you have shifted the electron, so here it is going to be negative here, right? Okay, so that is back bonding where electron rich and electron deficient are next to each other. So these are the three cases. Then there is next thing that we call as conjugation. In case crossed conjugation and extended conjugation. Cross conjugation is when double bond can be shifted here as well. It can be shifted here as well. That means two possibilities are there for different paths. Two different paths are there. That is called as crossed conjugation. And extended is when you double bond will shift here, this will shift here. That is on the same path. On the same path it is getting extended. That is called as extended conjugation. And always Extended is more stable than cross conjugation. Extended structure are more stable than cross structures always and always, right? Now, their stability. You have so many structures, how their stability will be told. Now, in case of stability of resonating structure, firstly we'll see the neutral. Neutral one always will be more stable as compared to charged. Okay. If I say, ma'am, all of them are neutral or all of them are charged, then in that case, what you will do? So if I say neutral is more stable than the charged, first case is when I say neutral is more stable than the charged. Then I say stability is equals to number of pi bonds. What do you mean by that? Why stability is equals to number of pi bonds? If I say all of them are charged or all of them are neutral, then I look for more pi bonds. More the number of pi bonds, more will be the stability. Let's say pi bonds are also same in all the cases. Then we will say negative charge more stable down the group. That means if I say O negative and S negative will be more stable. If I say O negative and F negative, then F negative will be more stable. We are saying negative charge is more stable down the group and along the period. Okay. Then if negative charge is also on same atom, then we will say more charge separation. Charge separation means, for example, this is carbon, carbon, carbon. Here charge separation is like this. Maybe in some other compound charge separation is like this. So here you have less charge separation, means more stability will be there, right? If more charge separation means less stability will be there. So charge separation and stability are opposite to each other. Then last is if I talk about any benzenoid ring. Benzenoid means when two rings are attached. So we are saying that separated rings, that means these kind of rings are more stable than the fused ring. That means when they are fused together, right? So separated are more stable than fused, and more is the number of rings, more will be the stability. Okay, more the number of rings. For example, I have this thing. I have these 3 rings. That is going to be more stable. That is going to be more stable as compared to these 2 rings. Okay, more the number of rings, more will be the stability. Then we say equivalent resonating structures are always more stable. This we talk about phenoxide and carboxylate ion. So we say that when I talk about phenoxide and carboxylate ion, we know that phenoxide, because I am just doing the revision, so you should know that phenoxide has 5 structures, 5 resonating structure, and carboxylate ion means CH3COO negative. It has only 2 resonating structure, but these are equivalent structures, and equivalent structures are always more stable as compared to even if 5 phenoxide structures are there. So this is always going to be equivalent structure are always going to be more stable as compared to any other structure. For example, I talk about this thing here, right? Now let's talk about resonance and mesomeric effect. What is the difference in resonance and mesomeric effect? When I talk about resonance, resonance is not due to some external group. It is like benzene ring is showing resonance with itself, right? But when I talk about mesomeric effect, it is due to some external group, like these lone pairs will shift here, like this NO2, it will take away the electron from here, like this will take away the electron, right? And this will be shifted here like this, right? This will be shifted here, this bond will shift here, like here you have lone pair, this will shift here, this will shift here. So it is because of some external group, it is defining whether electrons will be given to the ring, like in case of phenol and aniline, or electrons will be taken out of the ring, right? Now ma'am, do I have to learn when electrons will be given or taken? No. Simple is, when you have, simple thing is a very simple 2 ways we'll learn this, right? Where you don't have to learn all the examples, just remember this thing here. I'll write everything here, okay, regarding that. So see, you have any benzene ring, when it is connected to a group which has lone pair, then it will show plus M effect. If you have, let's say, any benzene ring, when it is connected to a group which has a negative charge, then also it will show plus M effect. And plus M effects are always going to be ortho-para directing. Ortho-para, because at ortho-para they will have negative charge. So they are going to be at ortho-para directing towards electrophilic substitution. Towards electrophilic substitution. When an electrophile, electron loving group wants to attack here, they will always attack on ortho and para position. So in phenol, aniline, you will always see ortho para products getting formed. But in this case, what you will see, whenever on the benzene ring you have a group, right, that is connected to a negative element, more electronegative element, always it will show minus I effect. Or on the benzene ring you have a group that has a positive charge, this will always show minus M effect, and minus M effect are always meta directing, are always meta directing, are always meta directing. Okay, towards, again towards, whenever electrophile wants to attack, it will attack on the meta position, because on ortho and para position it will have positive charge, so meta will have more electron density. So that is why meta will have more electron density. That is why meta position, that is why benzaldehyde, or you say anilinium ion, will see it in the next class, they all form this minus, they all show minus M effect. Achha, now here is this thing that always plus M groups are generally, we say they are generally activating because they are giving the electrons in the ring, and they are generally deactivating. Now why I am saying generally? Because there is one exception here, and that one exception I will write here, and that one exception I will write here. Okay, one exception that you have is halogens. So halogens show minus I effect also and plus M effect also. Minus I effect because of their electronegativity, and plus M effect because they have lone pairs present on halogen, right? But usually what happens, usually, like, see, OH, if you talk about phenol also shows minus plus M and minus I effect, but their mesomeric effect is dominating. But there is only one case where inductive effect is dominating, and that is this case where minus I effect is more dominating as compared to plus M. That is why, because of plus M, it is going to be ortho-para directing. But because here minus I effect is dominating, this is deactivating. So this is the only group. Otherwise, all the ortho-para directing groups are activating, but this is the only group which is ortho-para directing, but as well as deactivating because of this reason. Okay? Tell me, is that clear? Okay, now all of this you don't have to do, right? Because I have written it in just one go. This also you don't have to do. I have written all of that. Okay? This you can go through. See. So that's why it is written halogens show minus I due to high electronegativity, this due to presence of lone pair. In case of this, minus I is more this. Halogens are deactivating but plus M, so that's why they are ortho-para directing. Now we are saying rate of reaction will be less. So if I say you have chlorobenzene and you have phenol, which one is more activating? This will also show ortho-para, this will also show ortho-para. But rate of reaction will be more in case of phenol. Can you tell me the reason? Because in case of phenol, we have activating groups here, right? Okay. And you know what? Aniline is going to show even stronger, even more fast reaction here. Now, why aniline and phenol? Aniline will show even fast reaction because in case of aniline, you have less electronegative elements. So it can donate more easily. More plus M will be there as compared to OH. Okay? Got it, everybody? Now, these are the group C. In plus M effect, all of these will have electrons, that means lone pairs, or negative charge will be there. So you don't have to learn it, right? Then we talk about minus M effect. Minus M effect, all of them you will see are connected to an element which is pi bondedly connected to more electronegative element. All of these examples are same. Then if you have with benzene any group that is electron deficient like C positive or BH2 which is also electron deficient, so they will show minus M effect. Is that clear, everyone? Okay, tell me, is that clear? Now in case of carbocations, okay, now let's talk about the third effect, that is hyperconjugation effect. Right, everybody, tell me. Yes, everybody, tell me. Shall we talk about hyperconjugation? So here conditions are alpha carbon should be sp3, at least one alpha carbon hydrogen should be there, right? So alpha carbon has to be sp3. For example, if I talk about carbocation here, this is the carbocation and here you have CH3, and this is CH3. Then this is the carbocation and here you have CH3, and this is CH2 double bond CH2. Now we are saying alpha carbon should be, we can also do one more thing here. Okay. First you will have to find alpha carbon. This is carbocation, so this is alpha, this is alpha, this is alpha. This is carbocation, this is alpha, this is alpha, this is alpha. First is alpha carbon should be sp3. So this alpha carbon is not sp3, this one. So it will be neglected here. These two are left. This alpha carbon is sp3 but it does not have any alpha hydrogen. So this alpha carbon is also neglected. So here you will have 3 plus 3, 6 alpha hydrogens. Here also you will have 3 plus 3, 6 alpha hydrogens. Okay, understood, right? Then same is with the case of free radical, also will be same thing here, right? In case of free radical, for example, I have something like this, CH3, this is CH2, CH3, CH3. This is free radical, this is CH3, this is CH3, this is CH3. Now tell me which one will be more stable. Carbocation and free radical are same only. This is alpha, 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 this is alpha. So in alpha, all the alphas are sp3. Yes. There is no, it also has alpha hydrogen, this also, this, all of them have alpha hydrogen as well. So this is 2 plus 3 plus 3, that is 3, 3, 6, 7, 8. 8 alpha hydrogens. This is 3 plus 3 plus 3, that is 9 alpha hydrogens. So answer will be B is more stable as compared to A. Okay? B is more stable as compared to A. Right? Okay, next. Let's talk about alkenes here. In alkenes, you have double bond, right? Now, alpha is that is connected to this one. So this is alpha. Let's say this is CH3, this is CH3, this is CH3. Okay, let's say this is here CH3. Now, if you want to see how many alpha here, this will be the main. This is alpha, this is alpha. This alpha has 3 alpha hydrogen, this alpha has no alpha hydrogen. So answer will be, in total it has 3 alpha hydrogens. Okay, understood? Tell me. Acha, then there is one more thing. In case of carbocation, what happens? The donation, I am just directly telling you the donation. Because see, hyperconjugation full-fledged mechanism, they will not ask you, but still you should know. So I am just telling you a bit about it, so that if they ask you statement based question, then you know what is there, right? Now in this case what exactly we do, in this case what exactly we do, let's say I am just erasing this thing here, right? Should I? Yeah, let's do that. Let's say you have a carbon, carbocation is here, this is alpha and this is the hydrogen, this is the hydrogen, this is the hydrogen. So what will happen here, what will happen here, this bond will be shifted here, so it will form, this bond will be shifted here, it will form a double bond here, and here H positive will be left. So that means electron transfer is taking from, this is sp3 1s. From this bond, it is shifting to this particular bond here, right? This is shifting to from this carbon to this carbon. Actually, this carbon is donating to this carbon, right? So actually what is happening, the shifting is taking place from, you can just write it here, you can just write it here, the shifting is taking place from which part to which part? It is taking place from sp3 hybridized carbon to sp empty p orbital. sp3 hybridized carbon to empty p orbital, it is taking place, right? In this case what will happen, this is not empty p, this is half filled p orbital. So you can say here sp3 hybridized carbon to half filled p orbital, okay? And in this case what will happen, here you will have a different thing. Here this is C double bond C and alpha will be this hydrogen here. In this case what exactly happens, this double bond is shifted here and this double bond is shifted here, right? So what exactly happens, this is C, this is negative, this is C, this will be double bond C and this will be H positive. So this is a hyperconjugation. Now here what is happening, this is shifting from sp3 to which part? This is pi orbital and this is shifting to pi star, that means anti-bonding. This is very important, this is shifting to anti-bonding pi star orbital. This they can ask you in statement based question. Otherwise though you just have to know the alpha hydrogen, that is the question that they ask, or they can ask you a statement based question related to hyperconjugation, okay? Achha, let's see the next one, that is aromaticity. Let's talk about, guys, aromaticity. Let's see aromaticity here, everyone. Let's see aromaticity here. Tell me. Let's start with aromaticity. See, aromaticity is, right, let me see. Satyam is saying, anyone wants to talk with me, है ना? Then when no one talked to him, then he is saying, what is shift space? When you clearly know that we are at GOC, ठीक है? Then Balaksi, I don't know what she is doing here, she or he. Satyam is to doing nonsense, complete nonsense. In the chats though, most of the people are doing nonsense only. What about those who are actually studying? Tell me. Acha, tell me. Those who are actually studying, should I go more fast? Tell me. Apollo, I'll have to think about other students as well. If they want me to go fast, then I'll go fast. Right? Yes. Satyam, but you were only asking, na, anyone wants to talk with me. Then if you want me to ignore them, then why you are asking other students to talk with you? Are you here to chit chat? Okay, chal. Now let's talk about aromaticity. Aromaticity is of like two things we talk about, three things we talk about here. Aromatic, anti-aromatic, non-aromatic. First, we will talk about planar cyclic conjugated. Planar means all the atoms attached should be sp2, right? Planar means it should be sp2. This means it should be cyclic, and there should be complete conjugation in that ring. Conjugation should not break. If PCC, any of it is not followed, it is directly non-aromatic. Okay? If we say PCC is followed, then if it is 4n plus 2 pi electrons, it is aromatic. If it is 4n pi electrons, it will be anti-aromatic. And remember that aromatic has maximum stability, then you have non-aromatic, then you have anti-aromatic, then you have anti-aromatic. Okay, now I'll give you some examples of them. See, if I talk about all these examples, tell me also A, B, C, D I am writing here. Tell me also in the comment section, those who are actually studying and not here for chit chat, tell me which one is anti, which one is non, which one is aromatic. Okay, see, cyclic complete conjugation, double bond, single bond positive, and PCC is followed, 2 pi electrons are there. 2 pi electrons means it belongs to aromatic, because 4n plus 2 pi, if you put n is equals to 0, it will be 2 electrons. Then here you have 4 pi electrons, right? That will be anti-aromatic. That means it belongs to 4n pi electrons. This is complete conjugation is there. It is cyclic. All of them are planar. See, double bond is always planar. If in a conjugation, C positive or C negative both are planar. In the delocalization, both C positive and negative are planar. Right? So here also it is planar. PCC is followed. 1, 2, 3, 4, 5, 6 pi electrons is also aromatic. When you put 4n plus 2, you put n is equals to 1, it becomes 6. Okay. Then this one, 1, 2, 3, 4, 5, 6, 7, 8 pi electrons. It is anti-aromatic. That is 4n pi. When you put n is equals to 2. Right? Okay. Then E. It has 4 pi electrons. 4 pi electrons is again anti-aromatic in nature. What about this one? 1, 2, 3, 4, 5, 6 pi electrons here. 6 pi electrons is aromatic in nature. Double bond means sp2. This is also sp2. It is cyclic, complete conjugation is there. Electron is 1, 2, 3, 4, 5, 6. So already it is 6 pi electrons. That means it is aromatic in nature. Okay. Now let's talk about these. Now see, whenever on nitrogen or oxygen lone pairs are there, right? So see, if the lone pair is involved in delocalization, you will include it in pi calculation, pi electron calculation. For example, I have this lone pair. This lone pair is involved in delocalization. So that means this lone pair will not be included in hybridization. So this is not in hybridization. This is sigma, this is sigma, this is sigma. This will be sp2 only. This is included in delocalization. That means 1, 2, 3, 4, 5, 6, 6 pi electrons. That means it is aromatic in nature. Okay. What about these lone pairs here? Are they included in delocalization? No, they are not included in delocalization. Whenever lone pair is on the atom which is having double bond, then it is never included in. This is not double bond single bond. This is double bond single bond lone pair. That is why it is involved in delocalization. This is not involved in delocalization. So one lone pair, one sigma, two sigma plus one lone pair means sp2 hybridization. That means it is total 3. So sp2. Here you have 6 pi electrons, 1, 2, 3, 4, 5, 6. So that is why it is aromatic. This is pyridine, right? What about this one? These lone pairs are included in delocalization. So that is why 1, 2, 3, 4, 5, 6, 7, 8. 8 pi electrons means anti-aromatic. Ma'am, will I include it in hybridization? No. That is why because of 3 sigma, it is sp2 hybridized. Okay. Acha, tell me, what about this one? What about this one? Will it be aromatic? Will it be anti-aromatic? Tell me. Or will it be non-aromatic? Tell me everyone, will this be anti-aromatic, non-aromatic? Which one? Here I caught you. Tell me. See, 2 lone pairs you have here, right? This one and this one. But if you're not answering this now, please leave the class. Because there is no point. There's a big illusion that you are giving that if you don't answer in the class and you will get marks in JEE, I am not God, right? And I'll not say all that things ki attend my class and you will get marks. Attend my class, be attentive in the class, give answers in the class, ask the doubts and remember what I have taught you in the class, then you will get the marks. And make sure not to do silly mistakes in the exam. Only then you will get the marks after attending this class. Otherwise, there are so many YouTube content that is already even I have made, but all the students have not gotten like 99.9 percentile. Content is free on YouTube. Only those students who answer and attentive will get the marks. So answer it, right? So if you see this, 2 lone pairs are there, right? Now in this case, only one lone pair will be involved in delocalization. Let's say this is involved in delocalization. So 1, 2, 3, 4, 5, 6. 6 pi electrons are there. That means it is aromatic in nature. What about these lone pairs? These are involved in hybridization. So in hybridization, we have 1 lone pair and 2 sigma. That means 3, that is sp2. Got it? Yes, everyone? Got it? Chalo. Now let's talk about anulenes here. What about anulenes? Yes, everyone, let's talk about anulenes here. In case of anulenes, there are planar, there are non-planar anulenes. So if I talk about planar, right? Planar are 4, 6, 14, 16, 18. All these are planar. So they will be aromatic or anti-aromatic. But non-planar anulenes, that is 8, 10 and 12, they are non-planar. 8 is non-planar because it will have tub-like structure. Okay, that is this kind of structure. Double bond, double bond, double bond and double bond. Tub-like structure. So that's why it is non-planar. 10 and 12 are non-planar because of angle strain. Because hydrogen and hydrogen will have angle strain. That is why they will go out of plane. Okay, so that is why they are non-planar. That is why these 3 are non-aromatic. And in these cases, you will see if like you have 4, 8 is not there. 4, 4 to 8, 4, 3, 12, 4, 12, 4, 4, 16. These are, yes, these 2 are anti-aromatic, rest of it 6, 14, then you have 18. These are 6, 14 and 18. These are aromatic in nature. And what are actually anulenes? They are monocyclic. Only one cycle will be there. complete conjugation, monocyclic alternate double bond structure. And if I say 4 aniline, that means 4 electrons are there, 4 carbons are there. If I say 16 aniline, 16 electrons and 16 carbons are there. Okay, right? Done, everyone? Tell me. So I have also made it here. 8 aniline will have a tub-like structure that I have already made, and these two will show angle strain, like this and this will show angle strain, like here also they will show angle strain. That is why they are non-planar in nature. Right, everybody? Now let's see electromeric effect. Yes, students, are you ready for all of that? Yes, everyone. Let's see. Okay. So if I talk about plus C and minus C, right? Now if I talk about, let's say you have C double bond O, and we know that electrons will jump here. If electrons are jumping here and H positive is also attacking on same position, if the displacement of electrons, displacement, delocalization of electrons and the attack of reagent is on the same atom, that is plus C. And if I see that this is C double bond O and electrons are jumping here and Cn negative is attacking here, right? Because this is partially positive, so Cl negative will attack here. Now they are on the opposite position. If on the same position, if electron, this is on the same position, this is on the adjacent position. If electron displacement and attack of reagent is on adjacent position, that is called as minus E. Okay? Right? Chal. Understood, everybody? Tell me. Now we will, after this, we'll do acidic strain, the applications and all. Right? That is going to be super duper hit. You'll have like, because that I have covered in detail, right? Okay? Let's do that. Let's do now application of all of that. So application is stability of intermediate, acidic and basic strength is the application here. Right? Okay? Tell me. Ready for it? Ready for it? Yes, everybody? Chalo. Let's do that, okay? Let's do that. Okay. So here, when we talk about stability of intermediates, how do we write it? Stability of intermediates will talk about carbanion and carbocation both. In one go only I'll talk about carbanion and carbocation both. Acha, tell me, if I talk about carbanion, if I talk about carbanion, right, this is going to be carbocation, right? If I talk about carbanion, carbanion is when you give the electrons, it's like stress, okay? When you give someone stress, they will become unhappy. When you take out the stress, they will become very, very happy, right? And this carbocation is like money, right? So when you give someone money, they become very, very happy. So when you take out money from someone, they become very, very sad that why you are taking away money from me. So just remember this thing. Acha, one more thing you can directly remember here. Carbocation is directly proportional to electron withdrawing group. This is carbocation, 9. Electron withdrawing group. More is the withdrawing, more will be the stability. It is directly inversely proportional to electron donating group. And here carbocation is directly proportional to electron donating. More you donate, more stability will be there. And it is inversely proportional to electron withdrawing group. Right? Now let's talk about examples one by one. See. This is the exception. This is the exception. Now let's see this. How do you understand this? Let's see. Let's say this is carbon and this is carbon, and always you talk about BARHI Barhi. Right? Now there is no back bonding. Is there any back bonding? Back bonding is there. Back bonding is there. This is the back bonding. Lone electron rich, electron deficient. So electrons will jump here. So this will show back bonding. This will show back bonding. When there is back bonding, it automatically becomes more stable. Here you don't have back bonding. So automatically A becomes more stable than B. Achha, when I talk about this thing here, in this case, carbocation is connected to sp3 hybridized. Carbocation is connected to, this is sp2 hybridized. This carbon is sp hybridized. We know that electron negativity will be sp, then sp2, then you have sp3. Okay, this is the order of electron negativity. Okay, that is the order of electron negativity. Now, when I talk about electron negativity, I'll directly say this is sp3, this is carbocation. I need, for the stability of carbon ion, there is no back bonding here. If I talk about Barhi, back bonding is not here, aromaticity is not here, resonance is not here, hyperconjugation is not possible, because for hyperconjugation, other carbon should be sp3, but there are sp3, sp2 and sp, so we can't compare. Inductive effect will tell you what is the answer here, right? So in this case, inductive effect of, in case of inductive effect, that means carbocation is directly proportional to electron donating. So I will look for the one which has maximum plus sign. So this has electron withdrawing effect, this has maximum plus sign, so answer is going to be this. Okay? That's how you will answer this. Okay? I am just taking few examples here so that you can recall things. Achha, there was this exception here when you have 3-methyl and this is this. Now when I talk about Barhi, so back bonding is not here, aromaticity is not here, resonance we can see here, you have resonance. And here you have 3 inductive effect. And here you have 1 resonance. So according to us, resonance is more dominating, so answer should be this. But answer is actually this, because 3 times when you have inductive, this is the exception. Usually resonance gives more stability, but in this case, inductive effect is giving more stability, because 3 times inductive is more stable as compared to 1 time resonance. Okay? Understood? Let's talk about this example. This will also, give you a very, very interesting, very important thing you will learn from here. See, I have picked up the examples in such a way so that you know that why we are doing this, right? Okay? See. Now, when I talk about Barhi, back bonding we don't see here, right? But I'll tell you one thing. Back bonding you can't see, but whenever this is the situation now, this is positive. Always remember, when this will show minus M. Minus M means on ortho and para position you will have positive. So add positive on all the ortho and para position whenever you have something like this. For example, if they here it would have been negative, I would have negative on ortho and para position. Okay, understood? See. Now see, Bag bonding is not. Now focus on this step. Focus on this thing. Okay, focus here. Now bag bonding is not there, aromaticity is not there because of resonance. We have made this here because differentiating factor is not there in resonance. But hyperconjugation is present. Directly you will not be able to judge it, but indirectly it is there. To the positive charge, it is connected to CH3. So it is 3 alpha hydrogen. It is connected to CH2CH3. So it is 2 alpha hydrogen, right? This is connected to CH3CH3. So it is 1 alpha hydrogen. It is connected to one CH3, other CH3, third is CH3. That is only no alpha hydrogen, and that is why answer is A, then B, then C, then D. Okay, that is why this is the answer here. Is that clear? Is that clear, everybody? Tell me. Is that clear? Done? Tell me. Rahul, are you going in some other universe? Let me just sit for 5 minutes and let me just see your doubts here. Okay? Tell me now, what are the doubts that you have? I'm just sitting for 5 minutes. My legs are paining now. Tell me. I'll just. I am here only. Now ask if you have any doubts. Yes. But ask now, na, if you have any doubt. Tell me. Tell me, tell me, tell me. Any doubt? Yeah, you should definitely wait. I'm teaching you GOC, then you're going somewhere else. But why you don't have? I mean, you have Chat GPT, right? You have Gemini, you have Ved AI, right? So many things you have, right? You can ask. You have Google. You can ask your questions there. Ved is there. Ved to definitely will give you like full detail answer of that. So why don't you ask these questions to Ved? Ask me those doubts which are related to the topic that I'm teaching you. Why you asking me I'm teaching this, you're asking me doubts on I have not even started isomerism now. You're asking me doubts on isomerism. Have I taught ozonolysis? No. Have I taught isomerism? No. Then why will I answer this question now? Is this a doubt session? Tell me. Tell me. Which one, Shrey? Which one? Which one? Yes. Chalo. Let's now do acidic strength. Are you all ready for acidic and basic strength? Okay? Let's do acidic and basic strength. Okay? Let's do that. Let's do acidic and basic strength now. Let's do that. See, in case of acidic strength, first is acidic strength depends upon which thing? acid has a work of losing H positive. If I want this to be a good acid, this should be stable. That means acidic strength depends upon the stability of carbon ion that you have. And carbon ion will be stable if you have electron withdrawing group. So acidic strength depends upon the electron withdrawing group that is attached to them. This is the general order of acidic strength that you can go through. But now I'll tell you things that this all we have done. Acha, see. Now one by one we'll see few things here. First is acidic strength along the period and down the group. Okay. So when I talk about along the period, it depends upon electronegativity of an ion. Down the group, it depends upon size of an ion, right? So when I talk about along the period, it depends upon electronegativity of an ion. Now if I talk about this thing, this is down the group actually. Down the group, it depends upon size of an ion. So down the group, size increases down the group. That is why bond length increases. That's why to break the bond, it becomes easy. That is why acidic strength increases down the group, right? Because size increases. But when we talk about along the period, it depends upon the electron negativity. Along the period, this is carbon, nitrogen, oxygen, fluorine. Electron negativity increases. That is why along the period, the acidic strength also increases. So we can say along the period also acidic strength increases. Down the group also acidic strength increases. But reasons are different here, right? Then we have acidic strength in case of this also I have told you. In case of this, we have already learned that why phenol is less acidic as compared to acetic acid. Because here you have equivalent resonating structures. Even though you have only two, here you have 5 resonating structures, but they are not equivalent. That is why acetic acid is more acidic. Now let's talk about these three kind of questions here, where you have what? In this you have A, B and C. Now here what will happen, right? You have 3Cl, you have 2Cl, you have 1Cl. Here 3 times inductive, 2 times inductive, 1 times inductive. To have the acidic strength, more is the electron withdrawing, more will be the acidity. So that is why here you have maximum electron withdrawing. So answer is going to be A, B, C is the correct answer here, right? Okay, this so I told you why this one, these are equivalent structure. If you see this here, it has equivalent structures that are like this. It has equivalent structures which are like this. CH3CO, bond will shift here, bond will shift here. They are equivalent resonating structures. They are more stable as compared to phenoxide, different structures which are not at all equivalent to each other. So equivalent resonating structures are more stable, right? Then we talk about this thing here. Let's see. Wait a minute. This is actually not needed here. Okay, let's see. Let's see. If you talk about this compound here, see, this will depend upon when it will lose H positive, it will become this. When this will lose H positive, it will become this, right? Now we want to see which one is more stable. This is negative, this is lone pair, this is electron rich, and this also has lone pair. This is electron rich, this also has lone pair. Now firstly we need to see, is there any back bonding here? In case of Barhi, you see, firstly locate for back bonding. Now we know that out of sulfur and oxygen, every second element is electron valent. So sulfur is electron valent d orbital. Electron valence, and sulfur has vacant d orbital. So because of its vacant d orbital, it is electron deficient, and this is electron rich. So back bonding will exist here. Here you don't have any back bonding. That is why A is more stable as compared to B here, right? Okay. This one though, there is no need of this here. Wait a minute. Yes. Okay. Now let's talk about these examples here. Let's talk about these examples here. Let's see. See, if I talk about this thing here, you have three elements. Where first is, let me just, let's see. Okay, you have these three compounds. Here negative, and this also is electron deficient, this also is electron deficient. Here only this is electron deficient. Here you have no one which is electron deficient. So here 2 times back bonding will take place. Here 1 back bonding will take place. Here no back bonding will take place. So more the back bonding, more is the stability. So answer is going to be A, B, C. Right? What about this one? This is the general order of acidity. Firstly HCOH, then PHCOH, then CH3COH, then CH3OH, then water, then CH3CH2OH. Now here a question which is like a mixture of equilibrium and acidity they can ask you here. Where C, always remember, reaction move from strong to weak acid always. So if I talk about this reaction, will it be forward or backward? That depends upon which is strong acid. So if I talk about CH3COH and water, CH3COH is a stronger acid as compared to water. So that is the reason here we will say this is strong acid, this is weak acid, and reaction moves from strong to weak acid. That is why reaction is forward here. If I talk about this is alkyne and this is water. Water is a stronger acid as compared to alkyne. So that is why strong acid, this is weak acid, and reaction always goes from strong acid to weak acid. That means it is a backward reaction here. Okay. Tell me everyone. Now let's see this thing here. That is, if I talk about these two situations here, let's see. Wait a minute. Acha, okay. No, I have told you there. Okay. Now let's see this thing here, right? See, this is picric acid. Now a very important line I am writing here. On meta position, mesomeric effect is not operated. Mesomeric effect will not be operated on the meta position. This is a very important line. Okay, I'll tell you how this is a very important line. This is a very important line. See, if I talk about this thing here, on ortho position, minus I, minus M both will be there. Minus I, minus M both. Para also minus I, minus M both are there. So very strong electron withdrawing is there. In this case, this is 3 groups are there. On para, you have minus I, minus M. On meta, you have only minus I. There is no operation of mesomeric effect. Right, this is only minus I because on meta position no mesomeric effect is operated. That is why overall it has less electron withdrawing group. That is why this is more stable, and that is why this is a better acid. Got it? Right? I am only picking very Ma'am, but H2 is beta. H2 can behave as an acid as well as a base. It is amphoteric in nature. Okay? Because CH3COH is a stronger acid. So there it will behave like a base. Okay, it is amphoteric in nature. Achha, now let's talk about ortho effect. Right? Now let's talk about ortho effect in the benzoic acid. Very carefully see that. See, ortho effect means what will happen. We are saying that exactly on ortho, like you have benzoic acid. So there are 2 things that are possible here. One thing is this kind of donation is possible. Double bond will be shifted here. I'll just write it like this. This kind of donation is possible. Other is this kind of donation is possible. Right? So cross conjugation is happening here. Right? But when you have here, what you have here, what is happening? Cross conjugation. So you can write here, cross conjugation is happening. Cross conjugation is happening here, right? In this case, when you have a very big group here that is attached, it will cause repulsions here. That is why this whole thing and this will move out of plane with each other. Okay, that will move out of plane with each other. So see now what will happen. See now what will happen. So if I say they will move out of plane with each other, this will be the situation. If I say they will move out of plane because of these repulsions here, then this will be the situation, right? This will be in one plane, this is the other plane. Now only one conjugation is possible, that is this negative is donated here, this is donated here. No cross conjugation. Because of no cross conjugation, this will become more stable, right? This thing will become, there is no cross conjugation here, this will become more stable. So what will happen? Whenever you have any group at ortho position, this thing will go out of plane with each other. That is why only one conjugation is here, and that is why it is very easy now to lose H positive because only one conjugation is taking place. So increase the acidic strength of benzoic acid, or you can just remember one line here. Ortho effect simply means that when you have any big group that is attached on the ortho position of the benzoic acid, its acidic strength will increase. Simple, simple, simple. Okay, right? And that group can be, if I talk about that group cannot be hydrogen, deuterium, tritium, OH, NH2CN. That can be NO2R, CHO and X. Okay. Now, next is the effect of hydrogen bonding. If you talk about hydrogen bonding, this can increase or decrease the acidity. Let's see how. Now, if I talk about it loses H positive, this will become this thing. Now, in this case, there is no ortho effect, right? Because OH is not a bulky group, so it will not show any ortho effect. Now, in this effect, what will happen? Here, hydrogen bonding will take place. When it loses H positive, here hydrogen bonding will take place. That is why it will increase the acidic strength here, right? Okay. For the ortho position, it is going to increase the acidic strength. Now, when I talk about this hydrogen, let's say, see this thing. Here, this oxygen is making hydrogen bonding with this hydrogen. That is why intra-hydrogen bonding is there, right? Now, this is in case of ortho, because of intra-hydrogen bonding, it will increase. But now, let's talk about this situation. Now, let's talk about this situation. In this situation, what will happen? This is ortho, this is hydrogen, this is oxygen. Without losing hydrogen only, there is intra-hydrogen bonding. Now, in this case, this thing is becoming more stable. So, that is why this hydrogen is not free to lose. So, all in all, what we want to say, hydrogen bonding can increase or decrease the acidic strength. Okay? If after losing H positive you have hydrogen bonding, then this means it will lose H positive only, then hydrogen bonding will be there. So in this case, ortho will have more acidity as compared to para. Okay? But here without losing H positive, it is having intramolecular hydrogen bonding. So this hydrogen is not free to lose. So it will hesitate to lose H positive. So in this case, para will have more hydrogen bonding, and these two cases are very, very important here. Very, very important. Okay? These two cases are very, very important. Right? Okay? So it can decrease, increase both. Right? Achha, this though we have done. Right? Then when it shows plus M, minus M, all of that. Achha, wait a minute. No. This is actually not that. Now, before we move further, this is like a important thing for you. So just remember this. OH, NH2, OCO, CH3, all of these, they will show plus M and minus I both. But here minus I is less dominating and plus M is more dominating in all these cases, right? If I talk about halogen, they show minus I and plus M just like these. But here minus I is more dominating, that is why they are deactivating. But overall effect will be, now let's talk about overall effect here. Let's see. Overall effect of minus I and plus M is iodine. This is the electron withdrawing effect. Electron withdrawing effect, iodine, bromine, chlorine, and then fluorine. This is the overall effect. Okay. Then we say CCl3 will show minus I and minus H both, where minus I is more dominating. CO negative will show plus I and minus M both, where plus I is more dominating, right? Okay. Now let's see this thing, plus M due to lone pair. If I say plus M effect is due to lone pair, it is, now in this case plus M effect is only due to the lone pair. Here also plus M effect is due to the lone pair, but this lone pair is also involved in some other delocalization. That is why here plus M will be more dominating as compared to this one. Right? Okay? Now guys, these are the examples, है ना? Like tons of examples I have written here for you. Tell me. Wait a minute. This though ortho effect and acidity we have done. Wait a minute. This also we have done. I'm just looking, some things might be repeated, so I'm just looking at them. Okay. Chalo. Now let's see this, okay? Now let's see all these things one by one. Right? Okay? Let's see all these cases one by one. See. If I talk about this thing here, if I talk about this thing, in this case, this is phenol, phenol, phenol. This is also, all of them are phenol. That means there is no ortho effect here. In benzoic acid only there is ortho effect. Now we will only see the effects that are there, and these three things that I have written here, they will help you, right? Now if I talk about CH3, it shows plus H and plus I both, right? If you CH3 will show you plus H and plus I. That means it is donating. This will show you, OCH3 will show you plus M and minus I. Now when I talk about the acidity, I need withdrawing effect more. So withdrawing is in here, right? Here you don't have any withdrawing. So withdrawing will be here. So C is maximum acidic strength, right? I'll say C has maximum. Then here you will have A, which has no effect. And here you have plus M is more, right? So in this case, acha, one more thing here to notice. Wait a minute. That is, if I talk about this thing here, this has plus M, na? That is the problem. Here you have, this is also electron donating, this is also electron donating because of plus M. Now for acidic strength, we need when there is withdrawing, and these two are donating. So this, there is no effect here, so this will be maximum. After this, out of these two, this has donating effect, but there is no mesomeric here. Mesomeric effect will have more dominance as compared to hyperconjugation and inductive. So here, because of plus M, donating is so high that it will be least stable here, right? So what about this one? Here para position NO2 does not show mesomeric. Here on para position CCl3 also will not show any hyperconjugation as well. Hyperconjugation and mesomeric are not applied at meta position. So on meta position, mesomeric there is not shown. So this is also minus I and this is also minus I. Now in these two cases, which one will show more minus I? Which one will have more minus I? Because of 3Cl, this will have more minus I. That is why this is less stable here. Right? This is more stable, this is less stable. Okay. Acha, then talking about this thing here, again phenol, you have para, para, para. This shows minus M also, which is more dominating. This shows minus I, that is more dominating. This showed minus I, that is more dominating. Right? So we want withdrawing will give you more acidity. So withdrawing power will be maximum here because it is mesomeric. Out of these two, here you have only one, here you have 3 chlorine and here you have only 1 chlorine. So that is the reason this will have more withdrawing power. So in case of acidity, we need more withdrawing power here. So withdrawing power will be more in case of 3 chlorine than in case of 1 chlorine. So that is why in this case you have CCl3 then Cl. And here also, wait a minute, I just said the opposite. NO2 will have more withdrawing power as compared to CCl3. Okay? Because here this will be more withdrawing power as compared to this. Because of more withdrawing power, this is more stable. Now, when I talk about these three things, here you have para, ortho and meta. Now, this is important. In this case, para, you have minus I and minus M, so very high withdrawing. At meta, you have only minus I, and at ortho, you have hydrogen bonding. That is why it is very difficult to lose H positive. So here, because of very high electron withdrawing, this is maximum. After that, this hydrogen is not free because of hydrogen bonding, you have B. Then least will be this, which has only minus I effect here. So answer will be para, then meta, then para, then ortho, then meta. So you can also write it as POM, POM. Okay. So you can also remember it like this. Okay? Others also, guys, if you see this here, phenol, so 1 NO2, 2 NO2, 3 NO2. 3 NO2 will have maximum withdrawing, so maximum, then less, then less. If you talk about this thing here, very important. Now, fluorine, chlorine, bromine, iodine. All the halogen shows minus I and plus M. But I told you, overall effect will be what? Overall electron withdrawing effect is iodine, bromine, chlorine, fluorine. That I told you in the initial, like 3-4 pages back, I told you the conclusion of that. So that is why this has maximum minus I. That is why this is going to be the order. More the withdrawing, more is the acidity. Okay. If you talk about this one, on meta position, mesomeric effect is not applied. That is why here we are not looking at the overall effect. We are only looking at minus I, that means electron negativity. So electron negativity order is fluorine, chlorine, bromine, iodine. So fluorine has maximum electron withdrawing. That is the reason here it will have the maximum acidity here. So these two things are again very important. These two things very important, right? What about this one? Here you have OCH3, OCH3, OCH3. Plus, we know that here plus M is more dominating here. Here plus M is more dominating. Here plus M is more dominating. What about minus here? Minus effect is here. In this case, you don't have any plus M. So what will happen? We need maximum withdrawing. So in these two cases, you have plus M. In this case, you don't have plus M, so this will be maximum withdrawing. About A and C here, V plus M is in both the cases, but minus I will be differentiated based on distance. This is less distance, so more minus I, so it will be more acidic. So after B, you will have A and then you will have C. Okay? Then what you have here, next is, in this case, what you do? This is 1, 2, 3 again, bacha, see this. Huh. Donating lone pair. I don't know which thing you are. But I do this yourself, okay? If you're going to do this now in the chat box, then I'm not going to teach you here. Okay? So, please. What I am teaching you, what you are saying is completely opposite. Acidic strength. If you see this, again, no ortho effect will be applied, right? Now here you have hydrogen bonding. Here you don't have hydrogen, here you don't have hydrogen bonding. Hydrogen bonding, that means this will be difficult. Wait a minute, this one and this one we have done it. No, this one we have done it. OH-NO2 group we have done it, isn't it? We have done it here. Yes, we have done it. This is already done, huh? This we have done it. Acha, let's talk about this one. This one let's talk about now, ortho effect. In benzoic acid, you will have ortho effect. So ortho effect means ortho always is going to be maximum acidic. So always write ortho effect. So this is going to be maximum acidic. Write A. Now I have to compare B and C. This has minus I and this has minus I and minus M. So this has more withdrawing, that is why this is going to be more stable. So it is A, C and then B. What about this one? In this case, what you have, ortho effect is not there, right? Three different groups are here. This is minus I, minus M is more dominating. Here minus I plus M, minus I is more dominating. Here minus I plus M is more dominating. So overall withdrawing effect will be maximum here. Out of these two, minus I effect is here more dominating. So negative effect is dominating. So it is overall deactivating. That is why this is more acidic as compared to this. Because here plus M is dominating. Right? What about this one? Because of ortho effect in benzoic acid, this will be maximum acidic. This and this, it shows plus I here. CH3 shows plus H. Because hyperconjugation is not valid on meta position. So here I have not written hyperconjugation. But here hyperconjugation is valid. So it is plus H. Now out of these two, which will have more withdrawing? Here plus I is more, plus electron donation is more because two effects are involved. Here it will be less. So I will say here it will be more. So this will be less acidic because donation is more. Right? Okay. Then let's see this. Now in this case, fluorine, chlorine, bromine, iodine, no ortho is there. Now on the para position, minus I plus M both are valid, and electron withdrawing overall effect is iodine, bromine, chlorine, fluorine. So this will have maximum maximum withdrawing. So acidic strength will be of this order, right? But if on the meta position you have it, on meta position only mesomeric is not valid. So it is only minus I, and minus I effect of fluorine is maximum because of maximum electronegativity. So it will have maximum withdrawing. So it will have maximum acidic strength. So little things matters here, right? What about this one? Here you have CCl3, CCl3, CCl3. Ortho effect, no matter whatever is the group, ortho effect, this is maximum. So I can say A is here. Wait a minute. A here will be maximum. Okay. A here will be maximum. What about these two? Here you have minus I, here you have minus I and minus L. Right? So this is more electron withdrawing. This is going to be more acidic. So A, C, and then you will have B. Okay. Achha, tell me what about this one? Here ortho effect is there. So A will be maximum acidic. Out of these two, here only minus I is applied. Here minus I plus M both are applied. Here what will happen? Here because of this donation here, because of this plus M here, right? The electron withdrawing effect will be decreased. So here it will be less stable or less acidic as compared to B, because here purely minus I effect is applied. There is no restriction of plus M here, right? Then let's do this one. Again ortho, that is why it will be maximum acidic. Here you have minus I, here you have minus I and plus M. Now more withdrawing will be more acidic. So this is more withdrawing because here you don't have plus M, that is why ABC is the answer. What about this one? In this case, if you see both are ortho. Now ma'am, what I will tell? Both are ortho. So see here you will actually have, once you, here actually what you will see, that when you lose H positive, you will form hydrogen bonding, intramolecular hydrogen bonding. So here you will not be able to, if you lose H positive, you can't form hydrogen bonding here. Here you can form. So that is why this will be more acidic. Okay. If you talk about this one, in this case you have two ortho effects. No, actually this will not be answered based on ortho. Why? Because if you see this here, if it lose H positive, two hydrogen bondings are possible. So this will be more acidic. Here only one hydrogen bonding is possible, so less. Here no hydrogen bonding is possible, so it will be least. Okay. What about this one? All of them are ortho. If number of ortho effects is same, that means all of them are having the ortho effect. In that case, all have ortho effect. Ortho is dependent upon the size of the group. So this has maximum size, then less, then less. So ortho depends upon the size. Okay? More the size, more will be the ortho effect. More will be the repulsion. Okay? Now they are saying, if in one case you have two ortho effects, in one case you have one ortho effect, then which one will be valid? Where two ortho effects are there, that will give you more acidity. Okay? If you talk about number of ortho effects, acidity directly proportional to number of ortho effects. More the number of ortho effects, more is the acidity. And if number of ortho effects are same, then it depends upon the size of the group. Okay? Understood? Tell me. Clear everyone? Now we will talk about basicity. Tell me. Is there any problem? Now I'll just sit for 2-3 minutes and I'll see if you guys have any problem here. Let's see and let's look at your chat. Tell me. You can ask me if you have any problem. Because questions now they ask you not on individual effects, but they ask you on acidity basicity. That's why I have not cut anything here. I have tried to take most of the examples here. Tell me. After basic strength, I'll give you the next break. Okay, after basic strength, I'll give you the break. Tell me. Understood? Is there any compound except benzoic acid which shows ortho effect? In case of acids, only benzoic acid will show. Now we'll talk about ortho effect in bases as well. Okay? Done? Clear? Shall I move to the basic strength? Tell me everyone. Let's see if you're ready. Tell me everyone. If we shall start with the basic strength now. Tell me. Tell me everyone. Chalo, let's see basic strength now. Okay, let's complete basic strength so that, after like break, we'll do isomerism. Okay, understood? Rahul Bacha, see, at this point, equivalent structures are which looks equal, twins of each other. Okay, chalo, now let's see this. Acidity. Now if I talk about this thing, okay, acidity, we know that For acidic hydrides, as we go along the period, acidic strength increases. If acidic strength increases, then their conjugate base, that means after losing H positive, their basic strength will decrease. If I talk about acidity down the group acidic strength is increasing. That is why if they lose H positive, their conjugate base, their basic strength will decrease along the down the group. Okay, so if this we have seen in ionic equilibrium as well, if acid is a good acid, then its conjugate base will be poor. Okay, now let's see basic strength. Basic strength, guys, it depends upon electron donating group and it is inversely proportional to electron withdrawing group. Right, more is the availability of electron, you can say directly proportional to availability of electrons. Okay, this is the order. I would not advise at this point you should learn this order because very rarely they will ask you directly from the order, right? So you can skip this as well. Now let's see. Okay, let's see one by one some examples. If you see here in no lone pair, lone pair, lone pair. In this case, lone pairs are available. In this case, these lone pairs are withdrawn by this nitrogen. In this case, these lone pairs are withdrawn by this oxygen. As oxygen has more electronegativity, so availability of electrons will further decrease here, right? So that is the reason A, B, C is the basic strength order here. What about this one? In this case, these lone pairs are withdrawn, actually not withdrawn. You can say these lone pairs will have donation from this ring. These lone pairs will have donation from 2 rings. These lone pairs will have donation from 3 alkyl rings. So more is the donation, more is the availability, more is the basic strength. That is why this is going to be the order here. Right? Then what about this one here? In this case, this is the nitrogen, this is the nitrogen, this is the nitrogen. Which one is more acidic? These lone pairs have donation from 3 times. These lone pairs donation from 2 sides, and these lone pair have donation only from 1. So this is tertiary, this is secondary, this is primary. So 3 degree have maximum, then 2 degree, then 1 degree. That means BCA is the correct answer here. Achha, what about this one? In this case, these lone pairs can be donated to this part or these lone pairs can be donated to this part. Okay? So this is the nitrogen that is delocalized in 2 things. This lone pair is delocalized in only one part, that is this part. So here availability of lone pair will be less because lone pair is delocalized in 2 parts. So that is why we can say B is more basic because availability is slightly more as compared to A. Okay? Achha, what about this one? What about this one? Here lone pair are not delocalized, they are completely available because this nitrogen lone pair is not delocalized anywhere. In this case, these lone pairs if you see, these lone pairs these lone pairs are delocalized here, then here, then here. So these lone pairs are moving, these are delocalized. These lone pairs are not, they are also moving. These lone pairs are also delocalized here. So see, availability is maximum in case of A, so A has maximum strength, basic strength. In B and C, electrons are delocalized here also, electrons are delocalized here also, right? But here delocalization is more. Why? Because in this case, if it is not delocalized, then this conjugation will not take place only. In this place, without this lone pair also, they can get delocalized. That means without this also, they are able to manage the stability. That is why this is less available, this is more available. So C is more basic as compared to B, so answer is ACB. What about this one? Here lone pairs are delocalized in 2 ways, here lone pair is delocalized only in 1 way. So B is more basic as compared to it. All depends upon the availability of the lone pairs, right? Now let's talk about this one. Here if you see, A, B, C. In this case, lone pairs are delocalized here. Here lone pairs are also delocalized. Here the lone pairs are not delocalized. So A will have maximum basicity because lone pairs are available. In B and C, lone pairs are delocalized. But here the lone pairs are taken by Here the lone pairs are, in case of this, the lone pairs are taken by this nitrogen. Here the lone pairs are taken by this oxygen. So oxygen is more clever. Oxygen is more electronegative. So here the pulling of the lone pair will be more. So this will be less available. So that is why B is more basic as compared to C. In this case, again, lone pair here it is giving to 2 by 2 alkyl rings. Here it has Here it is only donation by 2 alkyl rings. In this case, there is only withdrawing by this nitrogen. Here it is withdrawing by the oxygen. So oxygen has more electronegativity, more withdrawing power. So this will be least basic. So A, then B, then C. Because here there is no withdrawing. In this case, there is withdrawing. There is more withdrawing here. Right? Achha, what about this one? In this case, always remember, cyclic structure is having more basicity as compared to open structure. So these two are cyclic structures. They have more basicity as compared to this open structure. Okay? This cyclic structure, it has one lone pair, and this has one lone pair where withdrawing is through the other nitrogen. So this will be more basic, this will be less basic. Right? Okay. Tell me. What about this one? This is also nitrogen. Huh? This is not Z, this is nitrogen only. Okay, this is nitrogen only. Wait a minute. This is nitrogen only. So now here this nitrogen is delocalized. This nitrogen here is not delocalized. So that is why A is more basic as compared to B. The one which is available, this is available because it is not delocalized. This is not available because it is delocalized. So basic strength is very, very simple. Okay. Now I'll directly tell you some important points on basic strength here. Let's see. Ortho effect. Okay, I'll just directly tell you that what exactly you need to learn for the exam, right? So ortho substitution, if it is case of 2 degree, 3 degree amines, then it increases the basicity. If ortho substitution is there in 1 degree amine, then it decreases basicity. Remember it as it is. Okay, this is a very useful point. Okay, this is a very, very useful point for your exam. For 2 degree, 3 degree, it increases. For 1 degree, it decreases. Right? Now, let's see what do you mean by that. Okay, all of this so you don't have to do, right? You remember it, that is a big deal. Wait a minute. Yes, this one will not delete. Yes, let's see. Okay, let's see one by one. Now here you have ortho effect, here you don't have ortho effect, but this is primary. So in case of primary, ortho effect decreases the basicity. So here basicity will be decreased. This is 3 degree in tertiary. Ortho effect increases the basicity. So that is why this A will be more basic as compared to B. Right? Then we talk about this thing here. In this case, C, all these are primary, right? So in case of primary, what you do? On ortho, what you have here, ortho effect, that is why ortho effect is least basic in case of primary. In this case, meta, only minus I is there, here minus I and minus M both are there. So whenever in basicity is directly proportional, wait a minute, it is inversely proportional to electron withdrawing effect. More is the electron withdrawing effect, less will be the basicity here. It will decrease the basicity, right? So we want donation. So that is why in this case what you will see, B will be maximum basic. B will be maximum because see, ortho effect means this is going to have least. So A will be eventually least here, right? B will be maximum here, right? A will be least here. Why C is in between, right? Because C is less basic than B because C has more electron withdrawing effect. Okay, understood? See the next thing. See this here. It has ortho, so ortho definitely is least basic. What about B and C? This has only minus I, this has minus I and minus H. Mesomeric and hyperconjugation is not applied. So only mesomeric. Now we need to see this has more withdrawing as compared to this, isn't it? And also one more thing, if I say minus I and minus I, wait, this will have more withdrawing because minus I is actually electron, it is distance oriented. This is closer, so it will have more minus I. More minus I means this will be least basic. So it will be B and C will be maximum basic here. Okay? So that's how you're going to answer this. What about this here? In this case, what you have? You have NH2CH3. Ortho effect means this is going to be least basic. So A is least basic. Out of these two, this has plus I and in this case it has plus H and plus I. So here donation is definitely more. That is why this is more basic. So answer is C, then B, then A. Right? What about these things? Tell me everyone. Tell me. Okay? Now let's see this thing here. What about these three? That I'll tell you later on. Firstly, let's see this thing. Right? So here you have no ortho. Here you have on para minus I minus M. This is minus I plus M. This is minus I plus M. So maximum donation is definitely there where you have plus M. So answer is B is maximum basic. After B, out of A and C, which has more donation? Here you have minus I. Withdrawing is from minus M effect. So that is why this is least basic. Very high withdrawal is there. So it is B, then C, then A. B, C, A. Okay. Achha, now let's see this one. This is, in this case, what you have, this is ortho effect. Here ortho effect will be shown. So in this case, these two are the exceptions here. These two are the very, very important exceptions. That is why I am telling you. This is specially written here exception. So in this case, it is supposed to be, this should be maximum. So exception is that here you can just remember it as it is. On aniline, when you have OCH3, it is POM. Answer is POM. And on NH3, when you NH2 aniline, you have OH, it is POM again. Right? Whether you have OCH3 or OH, answer will be para, ortho and then meta always. Right? Okay? Ortho is supposed to be least, but it is not least. That is the exception here. Okay? Chalo. Now let's see this thing here, ortho effect in case of basicity. Now in this case, we see all of them are showing ortho effect. So when ortho effect is shown here, but what we say here, when ortho effect is shown here and what you have here, see this very, very carefully, when ortho effect is shown, but you have here, see ortho effect is 2 degree, 3 degree, it increases the basicity. So more is the bulkiness, ortho effect depends upon size of group. More is the group, more will be the basicity, right? Achha, what about this one? Here you have 2 times ortho, 1 time ortho, no ortho, and this is primary. In primary, ortho effect decreases the stability, so here stability, basicity will be least. Here this will be maximum. So answer will be A, B, C, because in 1 degree it decreases the basicity. Okay? Now let's talk about these two things here. Let's see. Here in NH2 you have OCH3 and here you have OCOCH3. Here minus In plus M is there. Here also minus In plus M is there. So we'll have to see where you have more donation. So here donation will be less because this plus M, these lone pair are also involved here. That is why these lone pair will not be able to donate that much. That is why here availability will be less. So answer will be this. What about this one? 2 degree. This is 3 degree. Now always remember, no matter what, 3 degree always will be, because 3 alkyl group directly will donate. So 3 degree always will be more basic than 2 degree and then 1 degree. Right? Okay? Understood? Acha, last point, what we also see in amines, right? That is, in gaseous medium 3 degree, then 2 degree, then 1 degree is there, right? So in gaseous medium there is no tension, always this is the order, always this is the order of amines, 3 degree, 2 degree, then 1 degree. Okay? And out of this ammonia, remember ammonia is always more basic as compared to any amine. Why? Because sorry, ammonia is always less basic as compared to any amine. Why? Because in case of amines there is plus I effect by alkyl groups, right? Acha, remember in the aqueous medium, right? In the aqueous medium, if the alkyl part is methyl, it is 2, 1, 3, 2 degree, 1 degree, then 3 degree. If the alkyl part is ethyl, it is 2, 3, 1, 2 degree, 3 degree, and then 1 degree. This question is also very directly only they ask you this. Okay? Okay, tell me. Tell me. Chal, let's see. Is that clear, everyone? Tell me. Is that clear? Is there any problem here? Done? Tell me, is there any problem here? Done? Done, 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 done. Okay. Which one should I repeat? Tell me what. Can you repeat last 4 hours of class? Tell me what should I repeat? Tell me if there is any doubt. I'm looking at your chats. Ma'am, ortho effect is a little bit confusing. Yes, that's why I've given you so many examples here. Right? Okay. Ortho effect in case of benzoic acid increases the acidity. Ortho effect is not valid in any other acid, right? Except for benzoic acid. In case of your amines, right? When I talk about 1 degree, that is aniline, in that case it decreases the basicity. But for 2 degree, 3 degree, it increases the basicity. Okay? Done? Chalo. Now I will give you break of like 15 minutes, and after that I'll see you all, right, for isomerism, right? Okay ji, tell me. After this I'll give you break and then we will talk about isomerism. Is that clear? Yes, everybody? Tell me. Done? Chalo. Khushi beta, please go through the lecture again. है ना? When I have completed ortho effect, I was talking about aniline only. Then you're asking me, ma'am, in case of aniline also ortho effect happens. And in what other case I have taught you ortho effect? Huh? I don't expect this, guys. Please, right? Acha. हाँ. Chalo. Now I will see you all after 15 minutes and we'll do isomerism here, right? Okay, that is 4:20, so I'll see you at 4:40 p.m. Okay, I'll see you all at 4:40 p.m. Right? Okay, so see you all. The class will be not 4:40, I've given you 30:35. Okay, wait a minute, 4:35 p.m. Okay, 4:35 p.m. the class will be resumed. Okay, so yes, everybody, let me just sit, guys. My health is like not fine. Tell me, everyone, are we back? Yes, the break is over. Break is completed. Yes. Uh, tell me, everybody in the chat box. Na, 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 मेरी भीगे भीगे से पलकों में जैसे मेरे सपने बिखर के. Have you ever heard this song? I can see you guys are chatting like I don't know what. So I am also doing whatever I want. Right? I think you're a good singer. Okay. Thank you. Which Namrata ma'am is was not well on Jan attempt also, so she took a break, right? So that's why, and I also think I need a break. My body is also giving up now. Well, marathons are tough, yeah. Marathons are tough. My body is now like I am literally getting like, on daily basis. I am not well. Now that's a very basic thing. Like basic means it's a very like usual thing. And I'll tell also I'm not well. Everyone is like okay, okay, ma'am. Ma'am, good singing. I don't know Hindi song. See, I only know Hindi and Punjabi songs. So I don't even know English songs that much. So I can sing a Hindi song for you to refresh your mind before starting isomerism. Okay, I don't know if you'll be able to understand that or not. Yes, I do watch Lewis. I do watch that YouTube channel. Vetresium, yeah, that science, something about science they tell. I do watch it. Yeah, yeah, health is important. Actually, that's right. So 4 hours, so I was able to pull off. But after 4 hours, my energy is like I'm not able to stand only. So, yes, so I'll just sing one song so that I can also feel fresh, so that I can do isomerism after that. So, I'll sing, okay, now. मेरी भीगी भीगी सी पलकों में जाने तेरे सप I don't know what is the lyrics, okay? I'll just sing the tuning because I don't remember the lyrics. पलकों जाने तेरे सपने बिखर के जाने मन तेरा भी किसी के मिलन को अनामिका तू भीतर से मेरी भीगी भीगी सी पलकों में जाने ना 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 आने बनते ना भी किसी के मिलन को अनामिका तू भीतर से. You should have become a singer. I don't know. I definitely should not have. I can only sing some songs good, but song singing is like a therapy for me. So whenever my body is very tensed, like right now my body is paining, right? So my legs are paining, my head is paining again, right? So whenever I'm in that situation, you know what I do? I sing. I sing. So everyone has certain things. Some people play games, some walk, some sing, some sleep. I sing. And when I'm extremely tired, I will sing very beautifully, because when I'm tired now, it works like a therapy for me. When I'm not tired, I'm full energetic, I'll sing horribly. That's a fact about me. I sing horribly when I'm like not tired, I'm fully energetic. But when I'm tired, I'm not singing so that my every sur should be correct. I'm singing because I want to relax my mind. You know, after singing, my energy just lifted up. You can see this here, right? So before singing that song, my energy was so low, isn't it? Chalo. So let's see. Let's start, right? Okay. Yes. Let's start the class. So let's talk about isomerism. Acha, one more thing, guys. Today, I'll do only till isomerism, right? I'll give you a little bit recap of purification, qualitative, quantitative analysis, right? Just a quick recap, within 10 minutes I'll give you that. Go through that purification, qualitative, quantitative analysis. More I'm leaving it on you. I'll provide you it in the notes. Hydrocarbons I'll teach you tomorrow, right? So I'll club that. I'll teach you all the naming reactions and important reagents and distinguish test from full hydrocarbons till amines. Okay? Right? Okay? Biomolecules also I'm leaving upon you. I have done it multiple times. You can watch that. Purification also I'm leaving upon you. Okay, I can do one thing on these notes. I will add the notes of purification and biomolecules, right? Add those notes. Today I will give you purification for your homework. Do it yourself. I have provided you all the notes. I have done it multiple times. You can watch my Jan attempt also. I have done it. You can watch it there as well. Then tomorrow I'll give you biomolecules for your homework. I'll give you the notes. I'll provide you with the notes. Okay? Yes? Same time, 12 p.m. I'll see you tomorrow as well. Okay? Now I'll complete with the isomerism and that's it. Works for all of you? Tell me. Works, beta? So today, what is the work? Ma'am, what about practical chemistry? Beta, I will send you the link of practical chemistry. I have done it. Okay? So there is no point of doing that again and again. And my health is also not fine. So that is why, otherwise I would have definitely taken the class of practical chemistry as well. But body is not allowing, right? So I'll send you that link of practical chemistry. Go through that. Okay? Done? Chal. Shall we start with isomerism now? Let's see. So if I talk about isomerism, there are two kinds of things. One is structural isomerism, other is stereoisomerism. Structural isomerism is also called as constitutional isomerism. So in structural isomerism, exactly what we have done, we have placed atoms here and there. But in stereoisomerism, in structuralism, if I place my arm here, if I place my head here, if I place my face on the foot of, and if I place my foot here, that is structural when I am changing the positions, right? But if I talk about stereo, that means arrangement in the space. I am placing my head arm like this or this or this or this. That is stereoisomerism. Okay. So if I talk about structural isomerism, that is also called as constitutional isomerism. That is of chain, position, functional, ring chain, metamer, tautomerism. These are the types of structural isomerism that we have. In chain isomerism, the parent chain should be different. Like here 1, 2, 3, 4, 5. 5 carbon in the parent chain, and here 1, 2, 3, 4, 5, 6. 6 carbon in the parent chain. So parent chain is different. If parent chain is different, then we say they are chain isomers. In position isomer, the position of the substituent or the functional group will be different. Here let's see, this position is different. This position is 3-ol, this is 2-ol. So that is under the category of position isomers. In metamers, what you have here, in these cases, you have bridging ligands like ether, ketone, or you have ester, right? all these are the bridging ligands where what we do, we change the alkyl groups. Like you have CH3, CH2, CH2, OCH3, or you can also write it as CH2, CH3 on one side and CH2, CH3 on one side. So the alkyl group here, it was wait a minute, here it was propyl and methyl, here it is 2-ethyl. So I have changed the alkyl group only, that is why it is different. Okay, then we have functional isomers. In functional isomers, we have the same, see, isomerism means same molecular formula. Here functional group is different, like alcohol and ether are functional isomers. Then carboxylic acid and esters are functional isomers. Cyanide and isocyanide is functional isomer. Then we have ketone and aldehyde is functional isomer. So these are the functional isomer of each other. Then there is ring chain isomer. That means same molecular formula will be there, but one is ring and one is chain. That means one of them is ring and one is open chain. That is, they will have the same molecular formula, and usually it is between alkene and cycloalkane. They have the same molecular formula, but one exists as ring, one exists as alkene. Right? Then very important is tautomerism. So now this one is most important out of all the structural isomerism, that is tautomerism. In case of tautomerism, what you will say, that in this case condition as H positive intramolecular transfer is happening, alpha carbon should be sp3, at least one alpha hydrogen should be there. For example, this is the keto form, right? This is alpha carbon, which is sp3, and this is alpha hydrogen. So what will happen here, you will place it like this. This will be 1, you will place it like this. This will be 1, this will be 2, this will be 3. So what you will do, this bond will shift here and this particular hydride will shift here, right? So basically what we are saying here, everything else will remain the same. Everything else will remain the same. But here what you will see, that this double bond on 1 and 2 is shifted to 2 and 3, and the hydrogen on third is shifted to 1. So this is enol. This is converted to enol. This is keto form. That is called as keto-enol tautomerism. Okay, that is called as keto-enol tautomerism. Right? When double bond is shifted here and hydrogen is shifted here, that is keto-enol tautomerism. So there are two kinds of systems that we have in keto-enol tautomerism. First is 1,3 system, other is 1,5 system. Okay, so let's talk about 1,3 and 1,5 system. If I talk about 1,3 system, like here 1, 2 and 3 third position, oxygen and carbon are at 1 and 3 position. Carbon means that carbon from where the hydrogen is getting shifted, that is at third. That means the hydrogen on the third position will be shifted to the first position. But in this case, 1,5 system is applicable when the third carbon, here actually 1,5 system is not applicable. Wait a minute. Here it is not applied. Wait a minute. This is by mistake. I'll tell you where 1,5 system is applied. For example, you have something like this. Okay? Now this is 1, this is 2, this is 3, this is 4, this is 5. If the third position is sp2 hybridized, and that is why it is not able to show tautomerism, then only you can apply 1,5 system. That means now what will happen on the fifth position, you will have hydrogens. What will happen, this hydrogen will be shifted, this bond will shift here, this bond will shift here, this bond will shift here, and you will have this double bond as it is. This is OH, this is double bond, this is double bond, and you will have phenol. This is also enol and this is keto. Okay, so 1,5 system is only applicable if the third carbon is sp2. So this is a full chart that we have. We say that sp3 third carbon, if we talk about tautomerism here, firstly we'll check the third carbon. Chances are the third carbon is sp3. If the third carbon is sp3, then you will see if it has alpha hydrogen. If it has alpha hydrogen, then you will say 1,3 system, tautomerism is possible. If it does not have alpha hydrogen, then tautomerism is not possible. 1,5 system you will not see here. You will not see 1,5 system. But here you will say, if the third carbon is sp2, then you will say, okay, third carbon is sp2. Now, you will not see you will not see tautomerism on third carbon because one condition is not followed. Third carbon should be sp3. Third carbon is not sp3. So tautomerism is not followed in case of 1,3. But if third carbon is sp2, you will check the fifth position. If on the fifth position you have sp3 carbon with 1 alpha hydrogen, it will show 1,5 system. Okay. So if I talk about these two things, this is 1, this is double bond. Here it is 1, this is 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5. Third is sp2 on 1,5 system. 1,3 system is not possible. Then 1,5 system will look for 1,5 system. Fifth is also sp2. Here also fifth is sp2. That is also not possible. If you see 1, 2, 3, yes. Then if I see 1, 2, 3, 4, 5 and here 1, 2, 3, 4, 5. Here 1,3 system is not possible in either case. This also this because third is sp2. In this case 1,5 system is also not possible because 1,5 system is sp2. But in this case 1,5 system is possible. Here 1,5 system is possible because fifth carbon is sp3 with the alpha hydrogen. So 1,5 system is possible here. Okay. So 1,5 system you will only check in that case. Right. Okay, everybody tell me. Now we will see stereoisomers. Okay, from here also some very important questions are formed. Okay. Yes, everybody tell me. Done? See, it is of two types. One is configurational, other is conformational. So configurational means we are talking about geometrical or optical, right? And conformational will talk about conformers of alkenes here. We'll talk about conformers of alkenes here. Okay? So we'll talk about the conformers of alkenes here. Now, if you see this here, when I talk about configurational isomer, that is geometrical or optical isomerism, in that case, firstly, if I talk about geometrical isomer, that is a very simple way of predicting geometrical isomer. That double bond, this is 1, this is 2, this is 1, this is 2. On same carbon, you should never have same group. First carbon should never be equals to second, only then. First group should never be equals to second, only then GI is possible. For example, in this case, this is different, this is different. But in this case, this is CH2, this is also CH2, this is also CH2, this is also CH2. So this is same. That is why GI is not possible here. No GI. What about this one? Here methyl and hydrogen are different. But in this case, on this carbon, here you are meeting CH with bromine. Here you are meeting CH with chlorine. That means different environment is there. That is why we'll say that it will show geometrical isomer. Right? Okay. So, then we talk about, and in this case, restricted rotation should be there. That's why we are talking about only alkenes. Why alkynes do not show? Because alkyne do not have 4 groups attached. That's why this condition will not be satisfied. Okay. So only alkenes will show GI. For example, if I talk about cis and trans here, cis means on the same side. That means cis. And that means trans means on the opposite side. That means trans. Okay. So here if you see, will it show GI? No, because on the same carbon you have same group. So GI is not shown. Forget about cis and trans. If it shows GI, then only it will be deducted into cis and trans. If it does not show GI, then it is no cis and trans here. Right? Acha. Now in case of cycloalkanes, we will say if in a cycloalkane same group is present on the same atom, it will not show GI. Here if we see same group is present on different element, different carbon, it will show GI. Same group is present on same carbon, so it will not show GI. So same thing. Same substituent on different position only will show GI. If same substituent is present on same carbon, it will never show GI in case of cycloalkane. That is a simple trick. Okay? Right, everybody? Anti and syn and all, usually they don't ask you that, but still, right? If I talk about syn, right? Wait a minute. This was the, let me just recheck this. Wait a minute. Okay. So this is regarding OH and H. If OH and H are on the same side, that is called as syn. And if OH and H are on the opposite side, that is called as anti here. Okay? Done? Chal. Usually don't ask you that, but still we should know about it. Okay? Now let's see how to calculate E and Z. Right? How to calculate E and Z. See, I'm giving you very rare examples here because I'm just recapping everything here. Right? So just see the rules. This is CIP rule, Carl in gold and Prelog rule. More atomic number will have more priority. In case of isotope, more atomic mass will have more priority. So what we actually look for, we look for on the same side. If you see this, hydrogen and tritium, this more atomic mass, so this will have higher priority, that is 1. This will have lower priority. What about these two? CH2, CH2 is same. This will be cancelled. This is oxygen 18, this is oxygen 16. More atomic mass will have more priority. So this is 1, this is 2. So whenever things, E for enemy, enemies are always opposite to each other. When on the same side things are opposite to each other, that is called as E. E for enemy. That's how you can remember this. Okay. So see what about this thing here? In this case, you have on the same side, whenever there is triple bond, that means carbon is connected to 3 carbons. Double bond means 2 carbons here. C double bond C means 2 carbons and 1 hydrogen. So in this case, CC will be cancelled, 2 carbons will be cancelled, there is 1 hydrogen, there is 1 carbon. So carbon has more atomic mass, so that means this will have higher priority as compared to this. What about this one? Here C double bond O means 2 oxygens and 1 hydrogen is there. Here it means 1 carbon and 2 hydrogen. So definitely oxygen has more priority. So this will be 1, this will be 2. And whenever same group are on the same side, same, that means Z. Okay, so answer will be Z here. Okay. Achha. Then let's see how to calculate the number of geometrical isomers. For this, you just have to remember the formulas here. So for asymmetrical, usually they ask you for asymmetrical, but what if they ask you for symmetrical, then also you should know the formula. For asymmetrical, it is 2 raised to power n. N is the number of geometrical isomerism site, the sites that shows GI. For example, here, this site will not show GI. This is double bond, but this carbon has 2 hydrogens, so they will not show GI. No GI here. no GI. This is not a geometrical. This is a geometrical isomerism site where this carbon has two different groups. This also carbon has two different groups. One is hydrogen, one is this C double bond CH2. So this shows GI. So answer will be N is equals to 1. This is unsymmetrical. So GI should be equals to 2 raised to power N, that is 2 raised to power 1, that is 2. Okay. What about this one here? In this case, what you have, this is symmetrical. Okay. So in this case, this is symmetrical. This also shows GI. This also shows GI. So N is equals to 2. So for symmetrical, if N is 2 and that is even, if N is even, then P will be equals to 2 by 2, N by 2, that is 1. And the formula will be 2 raised to power N minus 1 plus 2 raised to power P minus 1. That means 2 raised to power 2 minus 1 is 1 and P is 1. 2 raised to power P 1 minus 1 is 0. So it will be 2 plus 1, that is 3. So that is why it has 3 geometrical isomers. Okay, so just learn the formulas, that's it. And they ask you questions of calculations of GI, optical isomerism, everything, right? Now let's move towards optical isomers, right? In case of optical isomers, we talk about that when you pass a plane polarized light from a compound, if the light is rotated towards the left, that is levorotatory. If it is rotated towards the right, it is dextrorotatory. And which is not rotated, that is optically inactive. But that is through the experiment, right? Without experiment, what we see that in case of optically inactive compound, either they should have any plane of symmetry present, that is symmetry should be there, or there should be chiral carbon that should be present if they want to be optically inactive. For optically active, this is not all are chiral. No chiral should be there. This is wrong. Okay? No chiral. No chiral carbon. If there is no chiral center and some symmetry is present, it is optically inactive. For optically active, there should be no plane of symmetry, no symmetry should be there, and at least one chiral carbon should be present. Only then it will show the symmetry. Only then it will be optically active. Is that clear? Acha. Wait a minute. This I will do later on. Firstly, let me talk about chiral center. Now I talked about chiral. What do you mean by chiral center here? Chiral center means sp3 hybridized and 4 different groups. For example, this particular is chiral. 4 different groups and it is sp3 hybridized. In this case, this carbon is chiral because 4 different groups. This is different, hydrogen is different, bromine is different, and it is sp3 hybridized. All of these are sp3, 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 but 4 different groups are not present. This is H2, H2, H2 is present. So none is chiral, only one is chiral. This one, this is sp2, sp2, this is sp3, but this has 2 hydrogens, so no chiral present here. Right? Okay? Now, let's talk about meso compounds here. What about meso compounds? Meso compounds have 2 chiral centers, 2 chiral. Plane of symmetry is also, usually when plane of symmetry is present, we say it is optically inactive. But if 2 chiral centers are there and one POS is present, we say it is meso compound, which is optically inactive in nature, right? Okay, even with having chiral also it is optically inactive. So what we say, 2 chiral centers, see here you have this is chiral and this is chiral. Okay, 4 different groups. The CH3, this is different, and one hydrogen is different. Same with this one. Here also this is chiral and this is chiral. So they both have POS. POS is present, POS is present. That is why they both are meso compounds here. Okay. Now let's see the next one here. That is, wait a minute. Wait a minute. अच्छा, this is the by mistake ligand है ना, just looking at something. Okay, chalo, I think perfect. See, now let's talk about this thing here, not this thing here. Let's talk about, we are almost towards the end only. Number of double bonds or rings. See this, if number, even if I talk about cumulative rings, right, that means you have double bonds next to each other, okay, or you have spiro rings here, okay, or you have spiro rings here, right, or you talk about biphenyl here. Chalo, when you talk about number of double bonds, if the number of double bonds in this case are odd, then definitely it is going to be inactive, because 1 2 3 4 4 double bonds, which is even. If the number, see, if the number of rings in case of spiro or in adjacent double bond alkenes, if the double bonds or the rings are odd, then it is inactive. If it is even, then if different substituent on one carbon, then it is active. If same substituent on same carbon, then it is inactive. For example, if I talk about this thing, okay, even number you have here, let's say on same carbon, you have methyl and methyl, this is chlorine and bromine, then this is inactive, because same substituent has same one carbon, you have same substituent. If let's say here you have methyl and here ethyl, then same carbon, different substituents, then it will be optically inactive, optically active. If I have this kind of situation, 3 spiro, then directly it is inactive. Similarly, if you have 3 double bonds or 5 double bonds, let's say, then it is odd, so it is inactive. If let's say there are 4 double bonds, and on the carbon, let's say here you have chlorine, here you have bromine, here you have methyl, here also you have methyl. So same carbon has same substituent, so it is inactive. If let's say here you have chlorine or here you have methyl, so different, same carbon different, same carbon different, then it is active. Okay, this is what I wanted to tell you here, right? Acha, next thing is calculation of optical isomer. Directly, guys, these are the formulas. Usually they ask you for unsymmetrical, right? That will be 2 raised to power n, but you can remember all of these formulas. Where n is what? N is the number of chiral centers, usually carbons, present in the compound, right? For example, here in this case, this is also optical, this is asymmetrical, this is also asymmetrical. Here chiral center are, this one is chiral, this one is chiral, so you can say n is equals to 2. Optical isomer will be 2 raised to power n, that is 2 raised to power 2, that is 4. Usually they ask you unsymmetrical only. In this case, this is chiral, this has different, this is different, hydrogen is different, this is also chiral. Similarly, this also will be chiral. These have CH2, CH2, so no chiral, CH2, CH2, no chiral, CH2, not chiral. So total number of chiral are 3. Optical isomer will be 2 raised to power n. For unsymmetrical, that is 2 raised to power 3, that is 8. Okay, that's how you are going to calculate this. Acha. Now, how to calculate the stereoisomers here? Let's see the calculation of stereoisomers. If you want to watch it in detail, all the classes are already there, right? But they will be 3-4 hours long, or maybe 10 hours long also. It can go up to if you watch it in detail, right? Which I will not advise 2-3 days before the exam. So do only this much, right? So stereoisomers, asymmetrical, 2 raised to power n. These are all the formulas that you should remember as it is. Now, stereoisomer, for example, this is asymmetrical. Okay? So here n will be Gi plus chiral. So this Gi will not be shown, because here you will have hydrogen and hydrogen. So this does not show Gi. This shows Gi, and this is a chiral carbon. This also is the chiral carbon, because this is different, this is different, this is different, hydrogen is different. So you have N is equals to 2 plus 1, 2 chiral and 1 GI, that is 3. So for unsymmetrical, stereoisomer will be 2 raised to power n, that is 2 raised to power 3, that is 8. Okay? Now see, ma'am, what is stereo center? Stereo center means 2 into GI. Stereo center will be 2 chiral are there plus 2 into GI. GI is 1. So you can just write it here, 2 chiral. Chiral is 2 plus 2 into GI. GI is 1. Because center in this GI, 2 centers are there. One is this, one is this, one is this, one is this. Total stereo centers are 4. Okay? But N will have the value 3. Is that clear? Done, everybody? Now, let's see, let's do some things here. What is RS configuration? See, RS configuration also very rare chances they will ask you this. So if you have never done RS configuration, please skip it. Okay? RS configuration, stereo calculation, I would advise all of you do. Optical isomer, till now whatever I have done in isomerism, do everything even if you are doing it for the first time. Because all of that is easy to understand. But this RS configuration, they don't ask you as such. That is why it's not important to do it, right? But still, if you have done it, then do it, right? Then don't take risk. But it's not something that you should just understand 1 or 2 days before the exam, right? So then you can skip it. See, lowest priority group on the vertical. See, what we say here, we say that if you have, let's say, any carbon, it has, let's say, 4 groups here. Let's say this is fluorine, this is hydrogen, that is CH2OH, and this is CHO. Now you have to define the priority here. Firstly, you will write the priority according to Karl-Ingold principle, right? CIP rule. Now in this case, you will look for the first atom. First atom is this is the first atom, this is the first atom, this is the first atom. You will only look for first atom. Here first atom is hydrogen and this is fluorine. So fluorine has maximum atomic number, so priority will be 1. It has minimum atomic number, priority will be 4, right? Now in this case, this means C double bond O, that means C 2 bonds oxygen and 1 bond hydrogen. This means carbon 2 bonds hydrogen and 1 bond oxygen. That means this has higher priority. So here you will say this is 1, this will be 2, this will be 3. Okay? Firstly, from Karl CIP rule, you will give the priority. Okay? That I have told you before, right? Now, Karl-Ingold principle is same only that we have done in EZ also. That is not different. Now, what is different here? If I ignore 4th here, then this will be 1, 2, 3, that is going from 1 to 3, that is going like clockwise. Now see this thing. Clockwise is R if 4th priority, lowest priority group is on the vertical position. Vertical is this. So if 4th priority group would have been on the vertical position, means here or here, then I would have said clockwise means R. But if I say 4th priority group is on the horizontal position, in that case clockwise will become S. That means here configuration is S. Okay? So usually they don't ask you directly R and S here, right? But how they ask you R and S, see this. So they ask you to identify an enantiomer and identical. So how do you identify? For example, 1 chiral carbon is there. This and these are 2 chiral carbon molecules. This is coming out to be S, this is coming out to be R. So if this is 1 is R and 1 is S, then they are enantiomers of each other. If both are R or both are S, that means their configuration is same, then we say they are identical in nature. Okay? Understood? Then if there are 2 chiral carbons, that means this is the situation. Now in this case we say both are opposite, that means this is maybe R and this is S and this is R, maybe This is also S and this is R, or maybe you can say this is R and this is S. That means both the carbons are opposite to each other in configuration, that it is enantiomer. If both are same means if this is S, this is also S. If this is R, this is also R. Then it is identical. If I say one is same, one is opposite, that means if this is R, this is S, one is opposite here. This can be R, this can be S, this can be S, this can be R, or one is opposite and other is same. This is R, this is also R, or if this is S, this is also S. Then it is diastereomer. And what actually are the definitions? Identical means superimposable, enantiomer non-superimposable mirror images, and diastereomers are not even mirror images of each other. Right? Okay? Chalo. Now let's talk about this. So I have already, chalo, let's do this fast. Okay? This is fourth. This is carbon, this is carbon, this is carbon. But this carbon has two oxygens, so it will be first. It has one oxygen, this will be second. This has no oxygen, this will be third. Now if you see, 1, 2, 3 is actually anti-clockwise. And fourth priority group is on the vertical position. Fourth on the vertical position, anti-clockwise means S. So this is S. What about this one? What about this one? This is 4, this carbon, nitrogen, oxygen. So oxygen has maximum atomic mass, then this is nitrogen, then there is carbon. So it is 1, 2, 3. Again, it is anti-clockwise, but fourth priority group is on the horizontal position. So anti-clockwise means it will be S here. Wait a minute. Sorry, anti-clockwise in that case means R. Okay, anti-clockwise in that case means R. Right? Okay. Now you can't say, ma'am, R and S are different. They are enantiomers. No. For enantiomers, they should have same molecular formula. Here I told you about if they have same molecular formula, then. Right? Same structural formula, then. Acha. Now let's talk about DLN configurations. For this we say, if the last chiral carbon has OH on the, just remember DR here. It is on the right side, this will be capital D. If it is on the left side, it will be capital L. And if I talk about this kind of situation where you have NH2 also here, let's say this is OH, this is CH2OH, this is CHO, here you have NH2 also. So here we say, if NH2 is also present in the compound, then we will ignore OH. And we will say if NH2 is on the right side, it will be D. Okay? Right? Done? Too much, na? Yes, it is too much. So, yes, then we have epimers. Epimers means in the diastereomers that differ in configuration. At only one chiral carbon, they are epimers. Like for example, here configuration is opposite. They are epimers of each other. Right? Anomers are the cyclic. We say anomers are epimers, but epimers may not be anomers. In case of anomers, we talk about cyclic epimers. In that case also, if you see here also, but in case of anomers, we talk about only first carbon. That first carbon has opposite configuration, that is anomer. In epimer, any carbon has opposite configuration, that is epimer. Okay? But in anomer, only first carbon. For example, epimer can have any. So here, here glucose and mannose, in this case, this carbon has opposite configuration. Okay? In case of glucose and galactose, fourth carbon, 1, 2, 3, 4. Fourth carbon has 1, 2, 3. Fourth carbon has opposite configuration. Right? Then let's talk about the last part of isomers, that is conformers of ethane. Right, everybody? Tell me. Right, everyone? Wait a minute. Yes. Tell me everyone. Beta, I'll give you break now. I'll give you bye-bye only now. Not break, I'll give you bye-bye now. Right? So let's see. Conformers of ethane. If I talk about stability order of ethane, see, in that what happens because of rotation, conformers takes place. For ethane, staggered is when they have angle between each other. So here you have angle of 60. Here eclipse means they are hiding each other. So eclipse because of repulsions is less stable and staggered is more stable, right? Talking about propane, you have one CH3 here because one hydrogen will be replaced by methane. So CH3 and hydrogen, they are staggered position, they have angle. When CH3 and hydrogen are overlapping each other, that is eclipsed. And again, staggered will be more stable as compared to eclipsed, right? In case of butane, it is very important that here two methyl will be there. When methyl and methyl are overlapping, they are fully eclipsed. When it is at an angle of 60 degree, it is gauche. When it is at an angle of 120 degree, that means methyl and hydrogen are overlapping. That is called as partially eclipsed. And when CH3, two methyls are anti to each other at 180 degree, that is called as anti position. And the stability order is of this. AGPF. What is the order? AGPF. Very important. This is, they have asked questions based on this. Anti-gauche, partial eclipse, then fully. Because anti-repulsions are less here, little more repulsions. Here are slightly more repulsions. Here maximum repulsions. Okay. But now we say that in case of gauche effect means when you have, let's say, this kind of situation where you have gauche is this na, gauche is this, okay. In this case, if you have, let's say, this is CH2 and one is OH and one is fluorine. Now in this case, in case of gauche, what happens? Gauche means two groups are like at 60 degree angle. Now they will start showing hydrogen bonding in this kind of situation. That is why it becomes, gauche becomes stable as compared to anti. Right? Now in this case, gauche is more stable as compared to anti. Anti means when these groups like OH and F are opposite to each other. Gauche is more stable. Gauche is more stable as compared to anti when it shows hydrogen bonding, right? Okay. So last is the conformers of cyclohexane. This is a chair, this is boat, this is twisted boat, and this is half chair conformers. And directly they ask you the stability of, wait a minute, this though will not do. Chalo, ring expansion, so I'll teach you rearrangement, okay? Rearrangement I'll teach you, okay? Let's see. Conformers, here it is. Wait a minute. Yes, oh, wait a minute. What is present in India? Okay, so here it is CTBH. That is the stability. Chair, then twisted boat, then half chair. CTBH is the stability order here. Okay, chair, then twisted boat, then half chair. Acha, last topic which I want to teach you before ending this class, that is rearrangement of carbocation. That will be useful. See, rearrangement is done because we want to move the carbocation into more stable carbocation, right? For example, let's say I have, this is carbocation, this is C, let's say this is also C and this is C. This is CH3, this is CH3, this is CH2, this is CH, and this is CH3. Now in this case, what will happen? This is carbocation is connected to 2 carbon, it is 2 degree. If here this hydrogen is not this hydrogen, wait a minute, this was a hydrogen, yes. If here this hydride is shifted here, then what will happen here? This will become CH3, this is CH2, this is CH3, CH3. And here you will have positive. So now this will become 3 degree carbocation. Okay? This will become 3 degree carbocation, and that's how we say that 2 degree and 3 degree, which one is more preferred? This one is more preferred, that is why rearrangement has happened. Now in rearrangement, we say the order is happy me. Happy, P means phenyl, me means methyl. Happy me. Always remember, you should remain happy. Okay? So now for example, if I am saying that you have carbon on which, now out of these two, you had two conditions. Either hydride can move or methyl. But which has more order? Hydride has more order as compared to methyl. So this would have been moved. For example, if I say here you have one phenyl. Let's say here you have one phenyl. Then which one will move? Again, you have phenyl, you have CH, you have hydride. Again, hydride will move. Why? Because that has more migratory aptitude. And now it is even more stable because of this resonance. So don't only see that 1 degree is converted to 2 degree, also see one more thing. For example, this is carbon, this is carbocation, this is oxygen, this is H. Okay, this is CH3, this is CH2, this is CH. Now this is 2 degree. If I shift this carbon here, then also it will be 2 degree. But still I am saying that rearrangement will take place. That means this hydride will shift here. Why? Because now it will form CH3, CH2, CH, carbocation OH. But ma'am, this is also 2 degree. Then why? Because here back bonding will be shown. So it's not only about degrees, it also depends upon if resonance is shown. After rearrangement, maybe resonance is shown, that's why we are rearranging it. This is resonance only, na? Back bonding is a kind of resonance, that's why we have done it here, right? And then the last one is your wait a minute, this so it will not show. Okay, let's see this. See, if I talk about this thing here, now we know that 4 degree. See, whenever we talk about ring expansion and ring contraction, in case of ring expansion, the positive charge should be outside the ring. Only then ring will be expanded. So you will have 1, 2 and 3. What you will do here, you will join this thing. You will break this bond, you will join this bond. So what you will do, you will have 1 and 2 here. You will break this bond and join this bond. Okay. So we'll break 2 and 3, join 1 and 3 and shift positive to the second position. What I am saying, break 2 and 3, join 1 and 3, positive is shifted from 1 to 2. Same thing here. If I have ring contraction, then positive charge will be on the ring. So here it will be 1, 2, 3. Same thing you will do. Break 2 and 3, join 1 and 3. So you will join 1 and 3 and positive charge will be shifted to the second position. Okay, tell me, is that clear? And why I have done this contraction? Because dancing resonance. One more thing, I think I forgot to tell you in resonance. Because this shows dancing resonance. And dancing resonance is most stable. If you see what is dancing resonance? Dancing resonance is this thing. When it is shifted here and it will be converted like this. This is dancing resonance, and dancing resonance is even more stable than back bonding. Okay, most stable thing, even more stable than aromatic, is dancing resonance. And anti-aromatic compounds are least stable. Most stable compounds are dancing resonance compound. That is this compound. Okay, tell me everyone. Now I will teach you hydrocarbons in the next class. Okay, wait a minute. Let me just delete all of that here so that I can pick up that in the next class. Okay, ozonolysis, everything I have done there. Now, because there is so much repetition that you will see in hydrocarbons, and oh, wait a minute. Wait a minute, wait a minute, wait a minute. Okay. Now, purification, qualitative, quantitative analysis I am giving you for your homework, right? Okay. Because all the things I have written here, okay, this is mostly theory only, and don't ignore this, right? All the reactions also I have written, everything is written here in detail, right? Okay, so you can just go through that. Those who want to go through purification, qualitative, quantitative analysis in detail, you can watch my lecture at 2x speed. Okay, would have done it, but my health is not allowing me, so that is why it's better that I give you notes and you do it yourself. Okay, right everybody, tell me. Chalo. Okay then guys, now I'll see you all. No worries, Louis, you don't have your exam, so chill, right? Yes. So okay then guys, I'll see you all in tomorrow's class, where we are going to do naming reactions and important reagents and distinguish test of hydrocarbons, haloalkanes, haloarenes, alcohol, phenols, ethers, aldehyde, ketones, carboxylic acid, and amines. Like today, I provided you the notes of purification, qualitative, quantitative. Tomorrow, I'll provide you with the notes of biomolecules. Okay? Chalo. Tomorrow also will be 12 p.m. only. Right? Okay? Done? Chalo. Okay then, guys. Now, I'll just save your notes here. Right? By the time you're typing. Okay? Done? Chalo ji. Okay then guys, now I'll see you all in the next class. Till then, bye bye. Bye bye everyone. Bye bye. And don't forget to put your comments in the comment section, because you know a lot of work I am doing for you guys. Yeah, I'm not fine, but I'm still here only because of you. Right? Chalo. Okay then, bye bye. Bye bye everyone. Bye.